Let's integrate Next.js with FastAPI. Our Next.js application will actually render out videos that our users will be able to interact with on however we see fit. Now, the idea of using Next.js comes because of AI. It's become a very popular tool to modify. So Next.js in the front end will rapidly change all of the time. But the thing is, we want to make tracking of those videos as easy as possible and as stable as possible. And so for that, we're going to be using FastAPI and a Postgres time series database called Timescale. Now, FastAPI itself is a Python web framework, but it's a minimal one at that. So you could deploy this as many times as you might need and not really need to change a whole lot, where the Next.js application itself can change rapidly and all the time. So basically our backend will be pretty stable. Our front end will rapidly change based off of users' needs. So technically speaking, we're going to be using FastAPI and something called SQLModel. SQLModel is a really simple way to create SQL tables, SQL database tables. Now, if you're not familiar with this process, I'm going to go at a high level as to what we do here. It's very straightforward, as we'll see. I also created a package on top of SQLModel that's optimized for TimescaleDB specifically and for series just like this. So again, the goal here is to have an analytics engine that can track all of our video progress. Google Analytics, as far as I know, will not give you the granular report that you might need to make decisions about videos, like which videos should you actually embed on your site and what should you do with them. If you actually control the videos yourself, you could do even further analysis from there. But the point here is we need to be able to track the videos and stuff before we invest in all of the things you might want to do on the back end or with AI and all of that. So my name is Justin Mitchell. I'm going to be taking you through this one step by step. I will have a rapid introduction of using FastAPI and the TimescaleDB package. I did do an analytics series altogether with those two, but in this one, it's much more about getting that whole project going so you have something that you can use right away. And the other part about this is this, I think, is a service you could provide to a lot of businesses. This guy right here, this freaking guy right here, is a reason that I think this is actually a good business. You can actually offer bespoke services to a lot of small businesses that need to track their video content. I create videos all of the time, and this type of analytics, it really does help make decisions on making new videos or just investing in videos continuously. Let's take a look at a demo as to how this thing's going to work. Let's do a demo of the final project that we're going to do here. First and foremost, jump over to cfe.sh/YouTube and grab any of the YouTube videos that I have. So what I'm going to grab here is my stock trading bot video, and I'm going to grab the URL here, and then I'll go ahead and paste it into my demo. I'll go ahead and hit play. There's that video. I'm going to go ahead and play it out. And of course, what's happening here under the hood is data is being tracked. If I just do a quick refresh on the page, I will see some of that data is now showing up. And of course, I can actually take a look at how this data is being played out through every few minutes, right? So notice that there's a total events of 8 from that one single video view. So if I actually come through in here and I make some more videos and I do some more moving around or I watch more of it, it's going to go ahead and track all of this in near real time. So if I refresh in here, once again, I've got 24 total events. My max viewership has changed, my average viewership has changed, but still only one unique view. That's because we also made view sessions. So if I were to open up a incognito window and take a look again, I just added a new unique view. If I refresh in here, it might not show up yet because I haven't hit play. So let me hit play in there and actually have some data come through. And so at some point in the very near future, I can refresh again and boom, now I have 2 unique views, but 36 total events. If you notice, that's a lot of events for very little activity on the site. And that's just how videos end up rendering out. That's how they end up working. So what we can do then is we can go to cfe.sh/GitHub and we can just take a look at the code itself. So inside of the repositories here, we've got a couple of them. We've got the video player here and also the analytics backend, the API backend. So the video player itself, like I mentioned in the welcome, is going to be rapidly iterated on. So we go through the process of actually building out a few hooks that are necessary for this, like creating a YouTube player that works directly with the YouTube API. We do all of this in line. We just make it all happen so that we can work through it. But the main thing here is this on state change. We are tracking every possible state event that can happen in this video, tracking and storing it in our backend. Now, if I wasn't using something as powerful as TimescaleDB, I would say you're not going to want to track all of that data. But since we're using Timescale and its powerful time series capabilities, we can track all of it. It's optimized and it does really well. So we can then use our backend, our FastAPI backend in here, which will allow for us to see the actual API endpoints itself in the video events. We look at routing in here, and what we'll see is we'll create all video events, literally all of them that are coming through with unique sessions. That's how we got that unique views in there. We add all of that data, it just adds in. Then we can start to look at all that data and we can aggregate it out so we can actually see what's going on with our data. Now, if you're not familiar with doing queries or query sets or any sort of database interactions, this part might be brand new to you. If you are used to it, the key part about it, especially when it comes to using Timescale, is this time bucket portion right here. It will allow us to bucket our data in different chunks. Timescale does that really well, and it's really, really simple to implement and get going. The model itself, especially if you're familiar with SQLModel, is not going to be a whole lot different. There's just a few other arguments that come in here that allow for it to be a time series database table, thanks to the TimescaleDB package that yours truly authored. But the idea here is we want something that is, well, pretty much easy to just plug and play and be able to track how all of our videos are doing, so that then we can get into some granularness of our videos. We can look at all of our top recent videos over the last however long period, and we can see what's going on. So in the last few minutes, what we should see is the video I just looked at, which sure enough, there it is, because that one has the most activity, because of course this is not fully deployed yet, but it is showing us all of this activity in here. Now, as far as I know, there's no real analytics out of the box programs that can do this, that can just wrap around your videos and give you this kind of granular data that you might want. Now, of course, we could always elevate it. Since we control the entire stack, we could always add in things like a user ID. We can track what users are doing individually, not just sessions themselves. So all of that stuff is actually, I think, pretty cool. Now, I realize the actual user interface itself could probably be improved a lot, and that's why I mentioned that AI is doing that really, really well. Even this page right here, I had help from AI just to make that part work. But all the logic, making sure all of that stuff works, is a key part of what this course is all about. So I do hope you take it and you take it with me. My name is Justin Mitchell. I'm looking forward to taking you through this one step by step. So let's go ahead and jump right in. Let's do a quick Next.js hello world, which is basically setting up our project. The idea here is you need to have Node.js installed. If you don't, you need to download it now. It is pretty straightforward to download and get it running. And of course, these are the versions I'm using. Now, I'm also inside of a folder called my dev folder. This is where I'll create the project with npx create next app at latest. And then I'm going to go ahead and use JavaScript. I'm going to use app router, and I'm also going to go ahead and use Tailwind itself. Then I'm going to go ahead and create my project as simply video player. And then of course, when we do the FastAPI, we'll do our video player API. I'll hit enter. We use ESLint. That's fine. The actual code in an SRC directory sounds good. TurboPack. I'm going to use all the defaults basically. We'll go ahead and run that as is. Now, the idea here, of course, you should know how to do this at this point. If you aren't familiar with this process at all, then this might not be the series for you. Next up, what we want to do is actually just run this project. So I'm going to go ahead and copy the link as to where it is, and I'll go ahead and do npm run dev. This, of course, will create the dev server and give us our little hello world on our local machine. There it is right there. Now, in my case, I'm also going to go ahead and close this out with Control C, and then do cursor period and open this up in cursor because that's where I'm going to be working going forward. Do keep in mind that I will not be using any of the AI stuff in the video. Feel free to do it as you see fit, but this is where we're going to be working now. So knowing how to toggle the terminal window is definitely a good idea, good skill to have at this point. So you can just run npm run dev and then toggle it at like that. So that's something you'll want to learn, and it's control tilde, little, squiggly line on there. But the idea here is, of course, you don't have to use cursor. You could use Windsurf, VS Code. There's a lot of really good ones out there. I'm just not using any of the AI features. Let's go ahead and embed a video into our Next.js application. Now, of course, the easy way to do this is by going into the videos on YouTube, grab any video. It doesn't really matter what video you're grabbing here. Click that share button and go to the embed side and go ahead and copy this out. Now, once you have something like that, you'll go back into your project, into like page.js, and then you'll go ahead and paste this in there. Now, I'm going to go ahead and remove some of the other things that we have and really just have the video on here so we can see what that looks like. I'm going to go ahead and save it. And of course, as soon as I go back into my Next.js application, I might get this error here for the invalid DOM property. I actually have heard that these properties are going to change in the near future. So this may or may not be an error in the near future, but for now it is. So every time you see one of those errors, you just want to change it to what it says. And then you're going to probably do this in a few other places like refer policy, as well as allow full screen, basically turning it all into camelCase. Now, cool, I can actually embed the video now and I can play it and do all of that stuff. That's nice, but that doesn't really do a whole lot in terms of what we want to work towards, which is not one-off embeddings, but rather any YouTube video. We want it to work basically the same way as YouTube. In other words, I'm going to go ahead and paste in this watch URL here. This is what I really want to have happen. This is what I'm going to go ahead and do now. So the way this works, of course, in app router is that we want to map what route we're going to use, like watch slash. That's the URL, or even without a slash there, that's going to be the URL we're going to map. So if I do page.js here, this will now actually handle that page. And all we need to do is export a default function. And I can call this something like our watch page. And then we just are going to return back something like h1. And we'll go ahead and say something like h1 watch this. And we save that. And of course, there's that page now being handled. Now, of course, there's a lot of improvements we can do to this. This series is not about the design of it. You can obviously use V0. You can do all sorts of things. This series is all about getting the functionality working and working well. So the functionality we need now is to extract this video, this URL right here, because that will help us inform what our actual embed is going to be. So going back into that original video embed, I'm going to go ahead and copy this out. And I'll go ahead and paste in here right underneath of what our video embed is. So really just that iframe, make sure it's closed off, all of that. So what we see, of course, is this URL here. So I can cut this URL out and say const URL equals to whatever that ends up being, put that into a string, and then we'll go ahead and use that as our src down here. And of course, at this point, it's basically the same video. It's always going to be the same video. It's not going to change. So the actual video ID is this one right here. So what we've got after that, we can probably get rid of, and really that's just the video ID. You can also test this by just refreshing that page, and sure enough, that video is showing up. So the question is, how do we actually grab the v equals? How do we grab the URL parameter here? Well, Next.js has something built in to do that. We're going to do something like search params, and we'll go ahead and do use search params, just like that. And here what I'm going to do is console log the search params that are coming through. That console log should probably come in on the front end. But as soon as I do this, I get this error here, and that's because it only works in a client component. In other words, I need to come to the very top and say something like use client, save that. This makes it a front end rendering, page versus maybe front end, maybe back end. Saying use client will definitely be on the front end or in the browser side. So now that we've got that, I can refresh in here. That page is back. I can inspect the element, go ahead and look at the console itself, and I've got my read-only search parameters in here. Now, there's a bunch of different ways on how we could use these search parameters. One of the ways I like doing it is something like this, where I come in and do video, or let's go ahead and just say V for a second. We'll call this V, and then we'll go ahead and do equals to object.from entries, and then pass in these search parameters. So basically, I'm deconstructing the object. That object is going to be all of the query parameters. In this case, it's just V, so V equals. But if I also did S equals to ABC and hit enter, that page will still load up, but the actual query param will not necessarily load up. And so what I can do now is I can take a look at that V, I can console log, and there it is. And of course, if I were to bring in that S, I can also do that as well, that other arbitrary parameter, and there it is, ABC. Great. So of course, we don't need that S. You could at some point, but right now we're not going to worry about any other parameters, just this single one, the actual ID itself. And so what I like to do with that is I like to use a colon, and then we actually can rename this parameter to something like video ID. So this renaming process then means that anywhere else I need to use the video ID, I easily can now. And then that becomes the parameter versus V, which makes it a little bit more tricky to use, I suppose. It's not that tricky, but I like verbose parameters or verbose variables like that. So what I could do is then in this URL here, we can actually just swap that one out. And there we go. So we now have a way to have a dynamic URL that maps very similar to YouTube. So we can try this out by just grabbing another URL. We can grab the Hans Zimmer song for time. We can bring this in here. We can go ahead and paste that in as well. Hit enter, and there's that video. So we can now map everything we want to do to YouTube. Well, this process is really nice that I can now embed these videos fairly straightforward. The downside of the way I'm currently doing it is, well, it's using the YouTube embed. I want to use a little bit different of a URL to actually embed these videos, so I have a little bit more programmatic control over the video itself. Right now, it's just about rendering it. Now we need to look at how we can actually use the YouTube API, if you will, inside of the iframe. Let's take a look. We now need programmatic access into the YouTube player. The way we're going to do that is by using the YouTube player API and not the embed code that we've been using. Now, this process is actually pretty straightforward with just pure JavaScript, but of course, we need it to be done inside of React and Next.js. So the way this is going to be done is very much like the actual iframe API reference. You can go off of that if you'd like, but the main thing here is we end up initializing a video with our particular video ID, and then we can actually monitor things that are changing over time. That's really the key of all of this, is to be able to monitor things. And of course, we can stop videos, play them. We can actually have programmatic access to how the video works. Now, do keep in mind, we get a little bit of data from the iframe API. What we don't get is a lot of data. That's where the YouTube data API comes in. This is where you can actually get a lot of granular data about a particular video, especially if you own that video. In our case, we don't own these videos. We're just using any YouTube video itself. So if you want to see me cover the YouTube data API, let me know in the comments. It is well outside the scope of this series. Let's go ahead and implement the YouTube player API as a React hook. So let's go ahead and jump into Cursor here. Inside of SRC, we're going to make a folder called hooks. Inside of there, we're going to go ahead and do use YouTube player.jsx. And I'm going to go ahead and declare the constant of use YouTube player. And it's going to take in a couple of arguments. We'll start with just the video ID, and then we're going to go ahead and return back an empty string. Since this is a hook, we want to export this as the default, which I will do just like that. And so naturally, I can use this now in my page here. I'm going to go ahead and come right below the video ID and say use YouTube player and just pass in that video ID just like that. Okay, great. So we'll adjust these things in a little bit, but we're going to come back into this player. So what is it that this needs to do? Realistically, it needs to load the YouTube API, script basically, and then it needs to, like embed. Let's go ahead and say embed YouTube video player, and it needs to track changes to video. Those are the three things it needs to do. Those are the primary things it needs to do. So how do we actually load the script here? Well, first and foremost, whenever you think of loading a script, especially in a hook, is you'll use something like useEffect in here. And this useEffect method, as soon as we do this, we want to make sure that this hook itself is going to be useClient. So when the actual player is being initialized, useEffect will be called, which is why we have the callback method in here and an empty array of dependencies. We won't need any dependencies just yet, if at all. So next up, what we want to do is we're going to go ahead and bring in our YouTube player API reference stuff. So if we look at the actual docs itself, we can scroll on down here a little bit and we can actually see we're loading the script itself. So that's this part right here. So I'll go ahead and copy that and we'll paste this in here. So as soon as I'm able to bring in the script, it's just a few steps here. We're going to create an HTML element called script, which of course is the same thing as just writing out script. We set the source itself, which is also the same thing as writing out source, just like that. But all of this happens asynchronously. Once we actually create the script tag itself, then we insert it right before all of our Next.js code. That's kind of the point there. Great. So once we have that, we can actually do window dot on YouTube iframe API ready, and make sure you have the correct, casing here. So Y, T, I, API, and R. Make sure those are all capitalized. So I'm going to go ahead and console log this and say YouTube is ready to roll. This doesn't mean the video is, it's meaning the YouTube iframe API is ready. So now that we've got that, and of course it's already in the watch page, we should be able to go back into our project here and we can see that YouTube is ready to roll. Great, so what is it that we need to do with YouTube itself? Now granted, going back into the documentation, what we see in here is this player being initialized and then some events related to this player being initialized. So what I want to do is I'm going to go ahead and copy this as reference really, and we'll paste it inside of this on YouTube iframe API ready. Okay, so I'll go ahead and tab this in here. And so what we've got is a function saying the iframe is ready. So basically, hey, what do you know? We've got this window function in here. So this is basically going to be what we do is we want to declare a YouTube player and then handle a few events related to it. So in other words, I can actually cut out these options here. So I'm going to go ahead and do that with const and say options equal to and paste those things in. So we've got a lot of video options that we can actually have in here. One of them being the video ID itself. So I should be able to pass that in because that's now an argument. This might need to be a dependency array item. So we'll go ahead and bring it in because it is dependent on the actual hook itself. So now we've got a few options for our player itself. Obviously, I can change these things. These events aren't ready yet, so I'm going to go ahead and get rid of them. Or better yet, let's go ahead and actually just declare some placeholders here where we console log out the onReady event and just see if that even works. We'll do that 2 times for the onState change as well as the onReady. So onState change. Great. And so the options are great. So we might want to call these something like our video options. Those are looking good, but the actual player actually working is not looking so great. So for now, what I want to do is I want to use the window.yt, all capitalized, .player, and this is going to be used in lieu of the other one, the actual new player or something like that. So basically, I'll go ahead and say new window.yt player, and then we'll go ahead and call this one, and it's going to be essentially using the, some sort of value here, and then the video options. I'll come back to that some sort of value in a moment. But I see that I have something that's not closed off correctly, so maybe it's related to this right here. Looks like it might be, and there we go. Okay, so what is this something here that needs to happen? Well, going back into the iframe docs, we see the very first thing that it mentions is the video player will replace this element here. I think this documentation could be just slightly more clear because the word player as the ID is not ideal overall. Because we've got a variable called player right here, and then we also have that same variable being referenced. What's referencing what? Of course, if you know JavaScript super well, you can probably figure out what's going on. But I like thinking of these, elements as actual arguments to the use a hook effect. So basically I would come in here and say element ID, and then I would come down and I would replace this string here as the element of ID. Now, of course, if there isn't an element ID being passed, I could do something along these lines, saying something like the player element ID equals to that element ID, or something like video-player. That's also an option that you might consider based off of how you might want to render this. Now, of course, if you're new to JavaScript, all of this might be like, what just happened? I have no idea. Hopefully you're not that new to JavaScript. And if you are, feel free to check with, Cursor AI or something like that. Okay, so the idea then is now we've got the YouTube video. It should be ready to go. It should be ready to roll with one huge exception, which of course is going to be this element ID. So going back into our watch page here, now we actually need the element ID in here. And so for this, I'm just going to go ahead and copy and paste some code for us. The first code is going to be related to Tailwind. So I'll go ahead and paste it in here. And that's just allowing for us to have a full width video container. So in here, this element right here is where I actually want to have my video player. So in here, I've got video player with that ID. We've got a class name in here and all that. So this video player is really going to take place of the iframe, this right here. And so the reason I have this is for that fallback. So I want to try out the fallback first. I'll get rid of the iframe because we shouldn't have that any longer. I'll make sure my project's running, and we'll go back into our video here, and there it is. So now it's full screen and it is responsive. So I should be able to do something like this and have a responsive video come through, which is exactly why we have these classes right here. The reason I have BG black in there is if the video for some reason does not load or does not work correctly, it pretty much clearly looks like a video should be there. Because it's completely black. But as soon as I bring the video back and I'm able to refresh, there it's going. So what we see here is this ID is actually working. The fallback for it is working on the hook itself, which we see that's what that video player is. So this fallback is really taking precedence or basically place of this ID and this one. But of course, like I said, I like to specify this anyway. So back into my page, I'm going to change this a little bit and call this my YouTube player, or better yet, I'm going to go ahead and say const the player element ID being YouTube-player, and then using this in more places than one to just make it that much more obvious as to what's going on. Hopefully all of that is very, very straightforward. So now what we've got is these events that should be coming through. So let's go ahead and go back into our project. Everything should render just fine. And I'll go ahead and inspect the element here. We'll look at the console and we've got on ready. That's all ready to roll and all of that. So naturally we'll need to do stuff with this data, but if I go ahead and play this, I can see these state changes happening. So these state changes are going to be a lot, especially if we start having a lot of videos playing. Notice that we can actually keep track of all of these state changes when we go forward. That's going to be the key here, is like, hey, how often is the user playing the video, or maybe going backwards or something like that. All of the keyboard shortcuts should still work, and all of those things should be rendered in the state change itself. So it literally gives us a whole new world of what we can track with a video itself, which is just not possible with that other embed as we saw. So of course now we want to start the process of actually tracking some of this stuff. So let's take a look at how we might do that. A big part of the reason I'm using a React hook is so that, sure, I can render out the video and it makes it really repeatable, but also so that I can actually return data back to whatever page that's implementing it. So in some pages I might want to track data, in other pages I might not. So the hook will basically allow me to do either one really simply. So the way we're going to track that data, we would do something like const player state and then set player state. And we'll go ahead and do the use state method here. And we'll go ahead and do something like is ready. And we'll start it off with false. And then we'll do something like current time at 0. Right? So basically handling the state elements themselves. So that then in a callback method, I can update those state elements. So in this onReady method here, I'm just going to go ahead and ignore this and go ahead and do set player state. And then we'll just go ahead and say is ready being true. And that's basically saying, hey, it's ready, let's go, right? That's it. Not a big deal. We will, of course, make it a little bit more advanced soon. And the actual player state that we have will be the thing that's returned. So that then in my watch portion, I can go ahead and say const and have my actual player state come through here, and we'll see what that looks like. And basically I would do something along the lines of, if it's not ready or ready, I would say something like player state, and then we'll go ahead and do question mark dot is ready. Then we'll go ahead and say ready and loading, something like that, right? So we can save that, and then we can refresh in here, and we should see that change states. And it actually corresponded to the video actually loading, right? Which is great. So that's a big part of the reason to use this. Now, of course, we want to go more advanced than just is ready. And so that's what I want to do now. The next part of this would be to actually declare a reference. So we would do something like player ref equals to use ref and say null. This player reference will allow for us to use this player element. So we would do player reference.current equals to all of that data. So this starts to get into the point where, hey, I want to use this player reference in this on state change callback method here, but I don't want to muddy up the callback methods right in line of this use effect. We don't want to add too many functionalities inside of use effect. So we want to change that one a little bit as well. So the way I'm going to do this is I'm going to first off go ahead and say const handle on ready, and we're going to go ahead and set it basically to this function right here. Just like that. And so we would come up here and set that here. But unfortunately, the way React works is you can't just declare the function this way. You have to use another hook, which is called use callback. And this is built in to handle this portion. And it works very similar to useEffect, but we have a callback function or some sort of function in there that we might want to use, including any parameters we might be passing. In this case, the event is being passed on the callback handler itself. And then there is a dependency array, which in this case we don't need. We're just toggling. Maybe we will need it later, but for now we do not need it. Okay, so there we go. We've got handle on ready. So if we did everything correctly, everything would work. I got an issue with use ref, it's not defined, so I want to make sure that I import that as well. There we go. And so now if I refresh in here, ready is still working with this new callback method in here. That's pretty much it. Now we'll see a little bit more advanced things with callback here in just a moment, but the idea is now we want to take it to the next step, which is using the state. This is where we're going to do all sorts of things. So realistically, we're going to go ahead and do const handle on state change. And it's going to be very similar to our handle on ready, but the way we actually set the state is going to be a lot different. So I'm going to go ahead and, give us a few lines in here so we can make this a little bit more effective for us. Great. So the handle on state change is now going to be up here. So now we've got a little bit cleaner in terms of our use effect method. We bring in the script and then we do all of this. All of that is looking pretty good. Okay, so now inside of this use or handle on state change, this is where we're going to do a bunch of things, especially related to our player reference here. So what I want to do is I want to see what our player reference is. So in this handle on state change, I'm going to go ahead and console log a few things. I don't even necessarily need the event in here any longer. I really just need to go ahead and do console log, and we'll do our player ref.current. We'll see what that is. And then I'm also going to go ahead and log in a constant that the YouTube API gives us, which will be window.yt and then .player state. Okay, so we'll log both of those things out and we'll refresh in here. So ready is going to go. The only way I can actually see stuff is if I play it. And then as soon as I play it, I see these two different values. The first one is going to be the player state, the YouTube like predefined player state. So we'll go ahead and do this constant as YouTube player state, object, which I'll just say is obj, and we'll go ahead and grab this value in here. Okay, so we'll leave that as is for a moment because we will come back to it. But the next one is the actual player itself, the current value here. So this is why we use that reference, is because now I can grab all of these things that are available to me. Get current time, hey, that's a good method that I might want to use. Get duration, that's a potential method I could use. But anyways, we got all sorts of functions in here that we can call inside of that get current. We also have things related to the video itself. So we've got player info in here. And if we scroll down a little bit more, we should have video title in here as well. And we've got all sorts of good stuff in there in terms of our video. Great. So that gives us just a lot of good data that we can now use, right, inside of our actual player itself, which is great. So we also have this method called get video data that we want to take a look at also. So I'll go ahead and do const video data equals to player ref, and then .current equals to, or rather .current.get video data. Okay, and then const the current time equals to the same sort of thing, player ref.current, and then it's going to be get current time. There we go. So let's go ahead and log out all the video data and also the current time in here just to see what we've got. We refresh in here, and now if I play it, I can see the video data is in here and the current time's right next to it. But unfortunately and fortunately, the only way I see this data is if an event changes. So on a state change. The state elements themselves are these right here. So what I want to do is I want to get whatever the current state is. So we'll go ahead and do const, current state, and this is going to be equal to, well, we need to get our player info in here. So once again, let's go ahead and do our const, and we'll go ahead and say player info equals to the player ref, and this is going to be just .current and player info. So inside of our player info, what we've got is our player state. Okay, and this is going to actually correspond to the object itself. Okay, so let me refresh in here again. I'll play it, and now what we see is we've got our video info. We've got a number that's going to be the current time, and then we've got another number which is going to be the current state, like one of these values in here. So the way I'm going to actually do this is I want to inverse this. I want to actually say from the value, as in from my current state, I want to get the key that's one of these YouTube player state objects. So the way I'm going to do that is just by copying and pasting a simple function called getKeyByValue. This is going to make a whole lot more sense in just a moment, but the idea is we'll go ahead and say the video state is equal to getKeyByValue. So we pass in the object itself, and then we actually get the current state value, whatever that might be. And now I will be able to see what is the state that I'm toggling between. So I've got my video data, my current time, and the actual key state. So if I refresh in here, hit play, hit enter, I can see now it says playing, paused. I do it again, playing, paused, buffering, playing, paused. I get all of these events now, and they're named. I might want to actually just store the number. I might want to do both. There is certainly a world as to where you could do both, and just remember what the mapping is. In my case, I like having it very verbose while I'm trying to diagnose what's going on in here, which is actually really nice. So it really helps me with toggling between what state is actually occurring in the video. One of the things it's not doing is actually tracking changes over time. That's something we will do very soon. But for now, I just want to bring all of that data into my player state. So I'm going to go ahead and say something like video data, and this is going to be an empty object to start. The next one is going to be our video state, right? So I'll go ahead and do something like video state label, and I'll go ahead and have that as an empty value, and then I'll go ahead and do my video state. Maybe we can say value in here as well. And that one's going to be, we'll go ahead and do -10, which is not a real value. So that's just a number that I'll remember. So now I just want to set all of those different items in here. So the way we're going to do that, of course, is by setting the player state. So we'll come down here and do set player state. And well, I'm going to go ahead and grab the previous value. So previous state. And we're going to go ahead and reset that value, right? So that's the point of this, is to reset the value if it ends up changing. And of course, the way we do this is not by doing that, but rather pushing in a function kind of where we go ahead and bring in that previous state, and then we update the values that are in there. And the values I want to use are going to be that video data, current time, and there we go, video state label rather, which I'm actually going to go ahead and do video state label in both places, just so it's not confusing ever. And then the current state, I'll also go ahead and do current state value in both places as well. We could call it key or label, doesn't really matter, but there we go. Okay, so now that we've got this, going back into our page here, we can now do something like a div, and I'll go ahead and just do, if that data exists, we'll go ahead and do we'll use JSON.stringify of that data just to render that out, just see what's coming through in there on our front end. I'll get rid of the console log there, and now I'll go ahead and hit play, and then it's going to go through all of that whole process. Now, one of the things you notice is at the very beginning, it actually removes all of those values. So I want to just come back into my state here a little bit where I'm setting this player state. I'm just going to go ahead and change this one a little to basically saying previous state and doing basically the same thing, because we did have a default state that we want to keep and only update the is ready basically. So we refresh in here now, and now there we go. So we've got all of that stuff in here. The video data is a good example of a title. So video data does have a title in there, which we can leave as an empty string. The reason I would do this then is inside of my page, I can say instead of watch video ID, I can actually do the player state dot the video data (title) and basically render that out. Let's see if that does it for us. And I'll refresh in here. And it looks like the video data is not quite coming through. I actually know why. Going back into our player state here, what I realized is this handle on ready should probably also call our handle on state change, because it will allow for everything else to come through in there. So I'll come in here and just call that as well. That should trigger that callback method, and then we actually get the title coming through in here. Might be kind of hard to see at the bottom of the screen, but the idea is it's now definitely coming through, and all of that other data is as well. And then if we go to play it, it should actually give me all of the data I might need and some more that I might not. The reason that it's giving us more, of course, has to do with this get video data in here. So maybe we want to have all of those data pieces, maybe not. Maybe we just want to have the title itself, in which case we would just go ahead and do the video data.title. I'll let you decide whether or not you want to have all of that stuff in there. You can get video quality. There's a lot of analytics you can add on if you needed to overall. But in my case, I want to just make it as simple as we possibly can. So I'll get the title, the state label, and all of that. It's queued up. It's ready to go. We are also ready to do the next thing, which would be tracking these same things over time. And it's actually pretty straightforward to do. Now, you might be aware is on YouTube, if you append &t equals and then some number, it will actually start the video at that number. It's a really nice way to resume something. So we want to support that as well. So we're going to go ahead and do the &t equals to some number and then change the start time for our video player. Now, before I actually grab it from the actual URL, I'm going to go ahead and go into our hook here and do start time and set it equal to 200 seconds just to go off of this. And then inside of our use effect, where we actually have our video options here, we're going to go ahead and add into player vars. I'm going to go ahead and do start in here and just bring in that start time, whatever that might be. Now, you actually don't need to put the key values into strings. This is just something that is done with older versions of JavaScript, which is why I would imagine they had that on the docs when we copied it anyway. So to find out additional parameters you might want in your player, so additional player vars in here, you can go back to the YouTube player API reference and scroll on down. What you're really looking for here is this player vars object. And then inside of there, you've got player parameters that you can then look at. And then again, you scroll on down, you can see all of the different parameters you have in here. And the one we're working off of is simply start. There's a lot of different ones. Some of them work, some of them don't. The start time definitely should work for you. But of course, it's definitely something worth playing around with. I just wanted to mention that because I think it's really useful. So next into our page.js here, this is where we want to be able to extract that parameter. So what I'm going to do is I'm going to say T. T is the key value that would come through, which is going to be the ampersand and T, right? And then the actual value itself, I'll just go ahead and say start time in here. So basically inside of my YouTube player, I'm going to go ahead and give it a start time. So I'll go ahead and do the final start time. So actual start is going to be equal to that start time if it exists. Otherwise, we'll just go ahead and do 0. I actually think that the arguments themselves would work without having some sort of fallback. So let's go ahead and take a look at that in terms of using invalid values for the start time in the YouTube player itself. So if I refresh on this video here and go ahead and try to play it, it should now jump to that 200 seconds. Let's change it to 500 seconds. And again, it should jump to whatever that is. Now let's go ahead and try something different, like some gibberish here. Then I go ahead and try and start it. It goes back to 0. So it actually doesn't need us to do any sort of checks whatsoever. The YouTube, iframe player will do that for us. So we don't really have to worry about that too much. Granted, you definitely could add in additional features like what YouTube has. YouTube has the ability to do 2M, and you can pass that in, and it actually changes it to the actual seconds that it would be, which is kind of nice. And probably has something for hours as well, but not all YouTube videos have hours. So with this in mind, we now want to do one more thing with our hook, which is going to be related to how often this handle state change is called. This one is also fairly straightforward. It is just simply an interval. So what I want to do is we'll call it something like interval. And this interval I want at every 5 seconds. So 5 times 1,000 will be the milliseconds. So that's every 5 seconds will be our interval now. So I'm going to go ahead and create another use effect here. And this use effect will actually handle the interval to, basically just call our handle on state change. This time what I'm going to do is get rid of the console log in here. So the actual console log will happen on the actual page that we're going to be using. So to do this, what we want to do is we use a built-in JavaScript feature called setInterval. This, of course, is a built-in to the client-side operations, and setInterval itself can work off of some sort of interval, which we actually did right up here, right? So that's our interval, and now we're using setInterval. Now, whenever you set an interval, you also want to clear it, especially with the use effect. So basically what we want to have in here is we return a cleanup function that will allow us to clear the interval, whatever that might be. Now in our case, we're going to go ahead and just do const we'll say interval ID is equal to that set interval in here. And there we go. So I set the interval and then I clear it. Inside of the interval is when I really want to trigger this handle state change. So we'll go ahead and call that just like that. It's the same as what we did on the handle on ready. Both things, right? It just works really, really well with this. Now, we probably don't need to pass it into our requirements here in terms of the use effect. It's not necessarily a dependency for it, but now we have this handle state change. We should be able to run with this. So I'll go ahead and do console log triggering change. And then on our page itself, I'll go ahead and console log our player state. And of course, the player state is also being shown on the page itself, which I want to make it a little bit easier to read also. So I'll go ahead and do width is, 50 VW or viewport width, and then I'll do MX auto, which should bring it in a little bit. And then the console log should be not in the return statement, but right above. There we go. And then I'll also add this div just around all of that data so it's all aligned. Okay, great. So now we've got our video here. If I go to play it, I should get the event happening every 5 seconds or so. It should actually show us what's going on with the video every 5 seconds. And sure enough, there it is. And if I inspect the element here, I should see that same thing, triggering change, and then it'll trigger change, and it'll keep doing that, and it'll do it every 5 seconds until I change. So this might not be what we want. Maybe if it's paused too many times in a row, we don't necessarily want to trigger that. But the thing is, to me, it's like, well, if they paused it and they're still sitting there on that page, well, maybe we want to keep track of that. Maybe we want to know that they're sitting there on this page and it hasn't been navigated away yet. That is something that I think would be a compelling thing to keep on here. So we're at a good point with our actual YouTube player. Now the next few steps will be very much about just storing this player state into our actual API service. Pretty much anywhere on our application, I want to be able to paste in a YouTube URL and then just navigate to the page that we are dedicating to that YouTube video. So the way we're going to do this is by using a Tailwind input form. It's a very straightforward process. If you go to tailwindcss.com into plus, into UI blocks, scroll down a little bit, or just do a quick search for input groups, you will be able to find the input group that we're going to use, which is this one right here. And of course, if you select React, it makes it a little bit easier on you. So I'm going to go ahead and copy this one out. We'll just grab that whole code here, and then we'll jump into our project. Inside of SRC here, I'm going to go ahead and create something called components. And then inside of there, I'm going to go ahead and create our YouTube URL form.jsx and just paste that in. As soon as I paste that in, what you'll notice is there's this chevron drop-down icon, which we'll need to import as well, or actually install it. And I'm just going to rename the actual function itself to the YouTube URL form. There we go. Naturally, we want to change this as to something like YouTube URL or video URL, something like that. Input is going to be the type of text still, which is fine. This right here, I'm just going to go ahead and grab a YouTube URL, a placeholder here, and then just paste that on in. That way we can have some sort of video. So we'll do video equals to, and then dot, dot, dot. There we go. And I'll call this my URL as the name. And yeah, we probably don't need this drop down, so I'll go ahead and get rid of that. I'll just grab div to div, and there we go. So we've got our input, and I don't need the $sign there. Maybe just a URL or something like that, and call that YouTube video. There we go. So I actually don't need to install the drop down at all because we're not using it. So with that in mind now, I'm going to go ahead and copy this and go into page.jsx and get rid of the iframe here. This, of course, is going to be my home page, and we'll change this to the YouTube URL form just like that. Let's make sure the div is still closed off in there. And if I did this correctly, it automatically imported it. Looks like it did. If I go back into my project here, looks like we're getting a incorrect something going on. So maybe I need to restart that overall, and we'll refresh, and it's giving us the incorrect yes. So the import here is just slightly different. So I'm actually going to rename this so it's not capital URL, but just lowercase, just like the automatic import happened right there. I'm going to do it everywhere because of that automatic import syntax that, maybe Next.js is looking for that. Okay, so there we go. So now I've got a way to grab this. I'm going to copy this YouTube URL here now, and we'll be able to paste that in, and eventually we'll actually be able to handle it. Right now it's not being handled at all because we don't have any of the logic in the form itself to handle that. So naturally the next step would be to handle it in the form. Now the reason I actually went this method versus something like so let's say ShadCN, which has great inputs, and I really like them. I think there's a lot of really good things about them. But if you actually went to do it right now, just by going off of the installation for any given input, it may or may not work correctly. This is definitely one of the things that I've been frustrated with ShadCN is they make a lot of great changes and they're also really, really good, but there's a lot of breaking changes that happen all of the time, which of course that's a good thing for progress. But when we need something really simple, I think just reaching for the latest trend of a front end may or may not be a good idea. So luckily for us, Tailwind gives us some examples in their Plus that just makes it really easy to work with and have a form that fits nicely in everything that's going on. I do recommend using ShadCN though. I think it's a really great tool. It's just outside the scope of what we want to accomplish in this series. So naturally we want to update the homepage a little bit, but the main thing here now is we actually want to implement the logic to extract the URL and then redirect the page. In a moment, we're going to implement the logic to extract the actual video from that form. But before I do that, I actually want to change the design overall. So I'm going to go ahead and copy and paste some code here into page.js. So I'm going to go ahead and do this one. It will change it to look a little bit more like this. And then inside of our actual YouTube URL form, I'm going to go ahead and paste this stuff in. And now it looks a little bit like this. So that I should be able to copy a URL now and paste it in here. Then I would basically hit play and it would take me to that page. This form itself isn't actually going to store any data. It's really just going to redirect our page. So we'll need to extract the logic that's coming through in here. Now, the way I actually did these things, and the reason I didn't show you, is because I used an LLM directly. So Command L, I used that directly to build out these two pages and change how they look, because that's what LLMs really excel at, if you ask me. They really do a good job on extracting how things looked and smaller functionalities. So one of those other smaller functionalities that I'll use is extracting the YouTube info. So grabbing out from regular expressions the ID and the time. Now, this is a very specific setup. So basically, it's not going to extract all YouTube URLs, really just the default YouTube URLs right here. So it doesn't have support for embed and all that sort of stuff. You could totally change it if you want to, but the idea is I want to run this function so I can get the video ID and time for this, mostly so I can just redirect to that next page. So of course, the way we're going to do this is we're going to go ahead and do use state. Something like this I would often put into a lib folder. So let's go into our src here. I'm going to go ahead and do lib and then extract YouTube info.js. And that's what I'm going to go ahead and put in there. So I'll go ahead and move that function on over. And then we'll go ahead and just export default function here. And then we want to import that. So extract YouTube info like that. Okay, great. So good starts as far as how this is going to end up working. Next up, what we need to do is track what the URL ends up being. And then when the button is pressed or when the form is submitted, we will go ahead and move the page itself. So what I want to do then is I want to grab what the URL value is going to be. So all I'm going to do is set a state element. So URL and set URL equals to use state. And then we're going to go ahead and put that as an empty string here. Then I'm going to go ahead and do const handle URL change. And this is going to be an event. And it's going to go ahead and basically take that event. So we'll go ahead and do something like this where it's set URL. And then we grab event.target.value. So then we can actually handle that data. So on change is going to be the handler. And then the value itself will always be that URL. Now, every once in a while, this might not end up being an empty string. It might be something different. So I want to make sure that I set it as an empty string by default. This is something I like to do just to make sure that of the empty string portion. It's not required, but we'll go ahead and say that the actual changed URL is equal to this event data if it exists. So question mark, otherwise it will be a empty string there. And there we go. Great. So what I want to do on top of this would be to extract the video data. So I'm going to go ahead and say something like video. We'll do video data, set video data, and there's going to be use state, and we need to grab the elements that we're going to use. So going back into extract info, we've got video ID and time. So basically I'm going to go ahead and put in here video ID is empty, and then time is also empty. So in other words, I should be able to take this changed URL and use that data. So let's go ahead and say extracted YouTube data equals to extract YouTube info, and then we'll go ahead and use that URL. This, hopefully, if we did it correctly, we can just set directly on here. Now, this can be a little confusing from time to time, so I also like doing something like video ID and time, and then that way my YouTube data is also very verbose as to what's happening when I'm setting this data in here. And time is one of those examples where if it is in there, then we want to set it, otherwise we'll put it in at 0. Now, we also have seen this as seconds otherwise, right? So perhaps we want to call the one we store in our state as seconds as well, but I'll leave it as is for now. In this form, what I want to do is I also want to just render out this data for a moment. I'll put a new div in here, and we'll go ahead and say if that data is there, then we'll go ahead and do JSON and .stringify of that data, just so we can see it. And it looks like we have some imports that we need to add in. So I'm going to go ahead and type it out again. Let the cursor editor bring it in for me. And we've got in a client component, and this says use state. Oops, I think I made a little typo there. That should be use client. And there we go. So we don't have a video ID or time yet. I'm going to go ahead and copy in this URL here, and we'll paste it in. We got an issue now. So the extracted info is not actually working. So let's go ahead and make sure we save everything here. And let's try it again. Paste in there. There we go. So we've got an ID in here and time. Great. So far so good. Now, one of the things that we didn't actually set is the next part, which would be if the form is submitted. So if they set a URL and it's submitted, what do we need to do? Well, first off, I want to make sure that this is required, right? This input needs to be required. Next up, I'm going to go ahead and wrap the entire thing in a form element here. And then I'm going to go ahead and make sure my button is a actual submit button. So I'll go ahead and do type equals to submit. There we go. Then I'm going to go ahead and do const handle submit, and there's going to be an event, and then we'll go ahead and handle it in here. So the form on submit, we'll go ahead and pass that in here. And at this point, we should have a video ID and a time value altogether. So what we want here is we want to bring in the redirect from our Next.js stuff. So I'm going to go ahead and bring in redirect here, and we've got our URL that we want to pass. So what is that URL going to be? Well, it's pretty straightforward. We're going to go ahead and use /watch. We'll do a question mark, v equals to the video ID. So we'll go ahead and use the $, and $, curly brackets, and it's going to be video data.video ID, and then and the time is equal to the time. So again, $, video data.time, and something along those lines. So handle submit would do that. But basically, if there is no video ID, then we would probably want to alert something. So something along the lines of, if not video ID, then we'll go ahead and alert needs a video ID. Otherwise, then we'll go ahead and do the redirect. Great. So let's see if this works. So I'll go ahead and refresh in here. We'll put the actual values in. We'll hit enter. And it looks like the URL went in, but it didn't do something. And that is event.prevent default. And then it should go through all those things. So let's try that again. Going into the home page, we'll paste it in, hit enter. There we go. Let's try it again with a video that we haven't been playing with. So I'll just go ahead and grab this one from Andrew Ng. This is a great video if you haven't watched it, but go ahead and paste that in there. Same watch, same link, all that. I'm gonna go ahead and hit enter. There we go. So that's exactly what we wanted. So now I can basically give the sort of user interface like you would want in terms of being able to track an individual video without needing to put it into a database. It just sort of works in that case. We're going to now update our watch page so that we can start emulating what we need to do with our backend. So that emulating is really just sending out this player state data. Now, the way we're going to do this is twofold. First off, we're going to go ahead and do something for use callback. What this will do is it will fetch to the FastAPI endpoint, which will then use the TimescaleDB database, which of course is a Postgres database for time series. To use that callback, we'll use effect as well. Use effect will call the callback function. So when it comes to use effect, what we can do, of course, is we can bring it in just like this with a callback method right inside of here and a dependency array. Now, of course, the dependency array will actually trigger the use effect to work. So we'll come in here and I'm going to now console log the player state right in here. I'll get rid of the old console log. I actually want to get rid of all console logs in the near future, but the other one being inside of the player itself. I don't want this triggering change in here any longer. Okay, so remembering back to the use YouTube player hook, we have is ready in here. So that's something I also want to keep track of in this use effect method itself. So let's go ahead and go into a video. We'll play it. And what I want to see is inside of the console, I want to see the objects coming back. I might want to change the actual interval that I'm using in here. So if I came in and changed the interval to, let's say, every 1.5 seconds, which would be 1500 milliseconds, we could say that, then we'll get a lot more events coming through with the data, right? We can ignore the YouTube stuff in here altogether, but the other data is now showing me everything that's coming through with this particular video. And of course, the other events come through in there as well. So the paused events coming through, and it's still actually sending the other triggers as well. So I'm going to try and capture all of that data. TimescaleDB itself is designed for a ton of data. So we should be in the clear for that, which allows us to really simplify what we do in this use effect and callback. Oftentimes what you'll see is if it's using another kind of database, you might need to build out something called a use debouncer or just a debouncer, which will slow down the rate as to what we would do with calling our API. I'm going to go ahead and see if this is even something I'm going to need to worry about. So inside of the use effect, one of the first things that I want to do though is I'll just say that if the player state is not ready, then I'll go ahead and return the callback itself. I won't actually go through the console log at all, which actually kind of makes sense. I don't actually think the is ready would even work in the hook itself if it's not ready. Like, in other words, none of these events would actually be working through if it's not actually ready itself. So with this in mind, I'm going to go ahead and now create the fetch method, which of course is going to be now our update backend, which we'll just go ahead and call use callback. So in here, what we want to do is we want to use an asynchronous call here, and we're going to go ahead and pass in the state. I'm just going to go ahead and call it the current player state, just to make sure that it's not confused with the other one. So we want to use asynchronous so that I can do something like await. Let's go ahead and do const response equals to await fetch. This is where we're going to go ahead and need to put in our API endpoint, which I'm going to go ahead and declare as a constant for now. And I'll go ahead and do temporary, API endpoint. And this is going to be HTTP//localhost. And we'll go ahead and do something like 8,000. And I'll go ahead and do API, let's do watch event or something like that, watch events. That will be our API endpoint, and I'll be able to change it when I see fit. Then, of course, the next thing in would be something like headers. We come in here and give it some sort of headers. And in this case, I'll just go ahead and do content type. And this is going to be our application/JSON. So it's JSON data coming through in here. And we'll go ahead and put that inside of our options, which is going to be our headers. Like that. We also want to put in a method in here, which is going to be most likely posting the data. And then, of course, we're going to go ahead and pass in some body data in here, which would be JSON stringify, and it's going to be based off of the current player state. I'm just going to go ahead and pass that to start. We'll see what that data is when we actually implement our backend, but for now, I'm just going to go ahead and do that, and we'll do something like if, not response.ok, then I'll go ahead and do console log error, adding data to the backend. Which, of course, there will be error adding data to the backend. There's no surprise to that. Okay, so with this in mind, I can now use this function in here. So instead of console log down here, I can actually just change it to the update backend, which is using that callback. Inside of that use callback, we've got an asynchronous method in here. And then the final thing that I might want to pass in this use callback is going to be our video ID. I just want to make sure that that's also available in this callback itself. So the player state, we may or may not need to have that in there. So I'm going to go ahead and do my video ID and my current player state. If I remember correctly, the current player state should also have that data. Like it should actually be coming back in it. But let's go ahead and take a look just to make sure. So I'm going to go ahead and refresh on this page here. I'm going to hit play. And right away, I can see that it's going to say failed to fetch a ton of times, right? Because we don't actually have a backend. But it is trying to send it, and it's going to continue trying to send it. My actual current player state, it didn't actually have that data. It didn't actually have the video data. So good thing that we actually added it in. So now I'm going to go ahead and change this a little bit to include that current player state data with unpacking it in there. And then the video ID is going to be simply the video ID. We might need to have additional data in here as well because it's not identifying this session in any way. It's not identifying it by a user or just a non-user or just, hey, this is a session that's going on. It's literally just taking the video itself, which might be enough. You might not necessarily need a session, but having sessions will help us better understand what's going on with our data. But there we go. We've got this data coming through in here. So what we've got is a problem with our fetch call, of course. So one of the things you also might want to consider is putting it into a try and catch statement, in which case you would come in here and just add in this response inside of that try and catch. Otherwise, we would say something along the lines of console log the error itself and just see what that actual error is, which means that it's not having the same kind of error being shown up. It's just actually handling the error now, which is the failed to fetch, the connection refusal in there altogether. We're not going to really spend a lot of time catching these errors. Much more, we're going to spend time to make sure that the actual backend is able to get all of this data and the amount that it's going to be sending in there as well. So this might be another thing where we've got a video state label here of queued. Maybe we don't ever want to send that data back. So this might be another one where we come in here and say if not, or if, let's say, player label, let's say player state dot video state label equals to queued, then we return that one back so that a queued video, we don't necessarily need that state. There, it's queued, didn't do anything. As soon as I go to play it, it's back to playing, then it's back to paused and all that. So a lot of different things on how we can consider handling this, but the point is, of course, our watch page will handle it in this method. We're now at a point where we actually need to build out our API, the actual FastAPI endpoint, and making sure all of that works and works really well. Again, if you send too much data in this method, especially based off of the interval you end up using, you could run the risk of just sending way too much data to where your backend can't really handle it. So that's where FastAPI and TimescaleDB come in a very big way. So let's go ahead and take a look at how we can make that happen. We're now going to build out our YouTube Analytics API by using FastAPI and Docker. Now, the reason we're using Docker is really to prepare our application to go into production as soon as possible, especially the backend that will handle all of the video analytics. We probably want to deploy that sooner rather than later. The front end is really going to be sending that data to the backend. Now, I have an entire course on this. It's the Build and Deploy Analytics API course that I go through all of this in a lot of detail. This portion right here is going to be a rapid fire version of really just implementing that and also using some of that code. So be sure to go to cfe.sh/github and then go into my repositories, do a quick search for the Analytics API because this is what we're going to be going through. Now, the link to the YouTube video, if you want to go into all of the depth and learn exactly what happens, feel free to do that. But for everyone else, we're going to go ahead and implement a lot of the features that we did inside of this one. Now, I will say you have to have Docker installed on your local machine and be able to run Docker PS like that. Of course, if it's not actually running, you would just open up Docker Compose itself, and then that would actually start running, and then you would basically be able to do Docker PS again and see something like this. This is at least where we want to be. If you see a bunch of container images listed out in here, you have it running and you are ready to go. Okay, so next up what we want to do is bring back open Cursor, and I'm going to go ahead and create a new project here. So I'm going to go ahead and open up a folder, and I'm going to go into my dev folder, and right next to my video player, I'm going to go ahead and do my video analytics API and hit enter, and we're going to go ahead and open this one up. And so what I'm not going to do is use the AI stuff. I'm just going to go ahead and put it right inside of this project. I'll also go ahead and say save workspace as the video analytics API. And I'm going to go ahead and open up my terminal here and do git init just to initialize a git repository because I want to do all of that as well. So now jumping back into the analytics API code, I want to remind you that we are doing a Docker-based approach. The reason we're doing this is to prepare for production. We want to put this live as soon as possible, regardless of what our front end is doing, so that we have more robust systems and capabilities to handle the sheer amount of data that's going to be coming through. So making it Docker-based means that whenever you look at code, you're going to want to look for a Docker file. You can start there. Every once in a while, you'll also start at the compose file or compose.yaml. I'm going to go through that in just a little bit, but I'm going to start at this Docker file right here, and we want to just go really quickly line by line as to understanding what's going on in this Docker file. So I'm going to go ahead and copy this raw file, and I'm going to go ahead and bring it on over locally, and in the repo, it is dockerfile.web. I'm going to give it that exact same name on my local machine as well, dockerfile.web. So what we see here at the very top is a version of Python that's being installed. Normally with Python is you create virtual environments, you install those packages in those virtual environments, and then you run FastAPI or whatever Python package you're going to be running. So this is useful outside of FastAPI. It's useful for Python in general whenever you're wanting to use Docker. Keep in mind, Docker helps isolate your project from anything else on your machine because it is, well, designed that way, and it's designed with Linux in mind. So the way all of this works is going to be true regardless of what your system is. Like I'm on a Mac, I could be on a Windows, I could be on a Linux. All of it is going to be basically the exact same, which is one of the huge benefits of using Docker. But what we see here is it creates a Python virtual environment. If you were doing this manually with Python, you would do that as well. Then it adds that virtual environment to the entire containers environment. Then you can install things related to pip. You can do other related things, system level installations. You can add the mini code directory where you're going to store your code. You can see that it changes it to the working directory. And here we go. We've got a copy command. You see a copy command. You need to think of, hey, does this file exist over here or does it not? In this case, requirements.txt does not. So I'll go ahead and do requirements.txt right here, just like that. I'll jump back into the repo. I'm going to grab requirements.txt. We'll copy that raw file. I'll paste that in there, just like that. We're going to go ahead and save it, and then we'll go back into dockerfile.web. We scroll down a little bit more. We see that it says copy the project code into the working directory. So what's the project code? Well, this says copy src. I don't have a folder called src over here. So I'm going to go ahead and create that folder. So if I look in the src folder here, I see that I've got a few other folders. Now, this actually will allow for me to do a bunch of things. I'm just going to go ahead and copy main.py or some of main.py right now. That is basically the portion of main.py. I'm going to go ahead and bring it into src. We'll go ahead and do main.py here. I'm going to paste it in. The things that I will not actually add in are going to be related to the third-party packages and all the other stuff that I might need to do in the near future. I'm just going to go ahead and have just this stuff in here. And we've got our hello world. I don't need this read item. I've got a very minimal FastAPI application. Now notice that there's a squiggly line under FastAPI. That's because my local machine does not have a virtual environment ready for this. We'll take a look at that in just a moment. But going back into the Docker file, let's go to the next step. We could obviously do this inside of Cursor as well. The next step is to install those requirements. This will be happening inside of the Docker. This will not be happening on ours just yet. Next, we see another copy command. Hey, what do you know? Copy command, we got to do something. In this case, it's going to be an actual file. This one was a folder because it actually didn't have an extension. That's usually how it ends up working. This one's a file because it does have an extension. So what I can do is I can make this file here. So I'm going to go ahead and just add it and paste it in like that. It's really cool. You can just do it just like that. And now we've got Docker run. So once again, going back into my code on GitHub, I'm going to go ahead and copy that file, and we'll just go ahead and paste it in just like that. You don't necessarily need to know what's going on just yet. If you have some familiarity with Docker, if you have some familiarity with FastAPI, it will help you, of course. But the main thing here is we see that main:app. Inside of the Docker run, main:app. What is main? Main is main.py. What is app? App is going to be the declaration of the FastAPI application. So that's how it's going to end up running inside of Docker at some point. We might need to see a little bit different very soon, but I just wanted to point that out because it is an important part as to why we have that script in the first place. So we see then is a little cleanup command, and then finally running that actual script, which is what's happening here. We copy it, we make it executable, and then eventually we run it. Great. That's our Docker file in, well, very little time. Okay, so after we think about the Docker file, there's a few other things that we want to think about, and that is a Docker compose file. So I'm going to go ahead and copy this one as well, and we'll bring it into here. We'll just go ahead and do compose.yaml. We're going to go ahead and paste this in, and let me explain a couple things related to this. First off, we got an image. We can name this whatever we would want. So in our case, I'm going to call this my video analytics API, and I'll leave it in with a tag of v1. Of course, I could go through this a lot, but this is an arbitrary name that I control. Build, this is going to build the container image based off of what you know, that dockerfile.web. Notice it's .web. That's important. We've got environment variables here, but they're commented out, so which that means I probably don't need them here. So I'm going to go ahead and get rid of them. But I do see that there's this .env file. I don't have those anywhere over here, so let's go ahead and make sure that we do. So .env and .compose, basically the exact same name here. This also might be in my repo. It also might not be. So let's go ahead and jump into the repo. And sure enough, it is in there. Now, the reason it's in there is because this is a tutorial. If I was going into production, I would not have it in there. It would be in gitignore, which right away I'm like, hey, these are secret keys. I need to make sure that I add in a .gitignore. This might be something you do initially anyway, but I'm going to go ahead and add it in now. Of course, the repo itself does have one. I'm going to go ahead and copy that, paste it in, and now I've got a gitignore file in there so I don't accidentally expose things I should not. In other words, if I were to copy the .env.compose to just simply .env, this one now gets grayed out. It is not going in there because of gitignore. Great, so back into the compose file, we now have done a few things related to this. The ports, the command, all of that stuff we'll come back to. Volumes, this is actually pretty important. We see that it's .src and it goes to /code. Hey, what do you know? As you may recall, the Docker file did the exact same thing. We copied the code from src and put it into a folder called code. That folder called code is inside of the Docker container. It has everything to do with that. So going back into compose.yaml, what this is doing is it's allowing me to use Docker Compose as a development environment. That's what's happening down here as well. So basically when we make changes to the dockerfile.web is what that should say, it's going to rebuild everything. If we make changes to requirements.txt, it's going to rebuild everything. If we make changes to compose.yaml, rebuild everything. So we'll see this in just a moment. We also see that there's a TimescaleDB service in here with environment variables. These environment variables should match .env.compose for the connection string. We'll probably have to adjust this a little bit maybe, but for now that should actually work. And that's pretty much it in terms of the application. So all we really need to do now is make sure that it is actually working on our local machine. Now, if it was using Python, we would have to go through all of the Python installation setup as well. We aren't using Python, we're using Docker. So I'm gonna go ahead and do Docker compose up and then --watch, hit enter. The --watch allows me to develop things. Cursor or your system might say, hey, we want access to data. I'm going to go ahead and say that's okay and let this go. So what we get here is we've got pull access denied for the permissions here. We've got a little bit of an issue for the actual image name itself. I'm going to get rid of the image altogether. I'm not going to actually use that one. I'll just go ahead and try Docker compose up watch, and we get a Docker files empty. It's possible I didn't save everything, so let me try that again, and we'll see if that ends up working. I did not save everything. Now I have everything saved. So what it's doing is it's building the container image. Notice that it ran pip install. It's doing all of the things that the Docker file is telling it to do, and it's doing it isolated from our system at large. It's not installing it into our system at large. Like my regular Mac will not have access to these things unless I were to grant them somehow. But for now, I'm just going to go ahead and run it. We see that all of this is coming in here, and we now have our project up and running. And so we've got it in here at port 8002. So what I should be able to do is open this on my local machine and see something like hello world. So that is the Docker and FastAPI hello world. I did this incredibly fast, or as fast as I could really, because I go into so much more detail on this course on all of everything that we just talked about, including using the Python version itself. Now, of course, if we wanted to use Python in here, what we would end up doing is saying something like Python 3 -- version. Just make sure that you have a version of Python on your machine that is Python 3. Then you would create a virtual environment. So Python 3 -m venv. Notice this is inside of my local project itself. That actually created this venv folder. Notice that cursor saying, hey, you just added one. Do you want to select it? I'm going to go ahead and say yes. Then the next time I open up a terminal window, it activates that virtual environment for me, in which case I can do pip install -upgrade pip. Now, you might wonder or notice that, hey, I'm actually running some of the commands that are in the Docker Compose file. That, of course, is done on purpose. And then, of course, I can actually go ahead and run my pip install again. This time it's not inside of the temporary folder, but rather it's just right next to where I'm running these commands. So I can run pip install requirements.txt. And of course, this is going to install it in my local virtual environment right here. Now that yellow went away in main.py because as far as my cursor is concerned, it understands, hey, this package is available inside of venv, which you could actually look inside of the lib, and you can see, hey, there's FastAPI, which is exactly where it's trying to import that. If I were to delete that again, what ends up happening is then I'll get these syntax errors that are coming through. Now, that is aside from actually developing inside of Docker. The cool thing about developing in Docker with that Docker Compose up watch, so let me just go ahead and close this out with Control-C to force it out. There it goes. This is going to be the command I'll always use, because if I do .watch, I can then come into something like main.py, and I can change this to hello world, my old friend, and save it with Command S. Notice that it actually restarted the application here, and then I could actually go into that home page, refresh, and there it is. Hello world, my old friend. All of that is working. Now, if you know Python well, you'll probably be like, okay, that makes a whole lot of sense. If you don't know this stuff, definitely check out the other things that I was telling you about. But the idea here is the reason all of this is working inside of Docker Compose is because of this command right here. This command is different than the Docker run command. The Docker run command, this one right here, although they look very similar, they are different in the sense that this one is for production, where this one right here is for development. That's it. That's the only difference. Of course, you might have questions about it still, but at this point, we're going to go ahead and move to the next part, which is actually ingesting the data from our Next.js application from the front end itself. Let's take a look. Let's create a FastAPI endpoint to handle event data, to at least have it come in before we start storing it. So the way we're going to do this is inside of src, I'm going to create a new folder called API by putting a slash and then a dunder or 2 underscores and then init.py, same way. This creates the actual API as a module. Next up, what we're going to do is another folder in here. I'm going to call it video_events and then do the same thing again with the dunder method init dunder.py. There we go. And then now we're going to go ahead and create routing.py, and we're going to go ahead and create our API routes. Now, in the long run, we're not going to leave it exactly like this, but I want to have a minimal version just so we can see the data coming through. So what I want to do is we're going to go from Pydantic. We're going to import something called a base model. This will allow us to actually design what data is coming through. So in our case, we're going to call this our YouTube player state, and it's going to take in that base model, and I'll go ahead and say pass for a moment. So what's the data that's actually going to be coming through in here? That's what we're thinking about in terms of this base model. Now, if you don't remember, inside of our Next.js application, inside of the hooks, we see the player state right here. So this is going to be the actual data that we want coming through in here. So I'm going to go ahead and copy this data, and we're going to go back into our YouTube player state here. I'm going to go ahead and paste this in here. Now, of course, I'm going to get rid of some of this stuff. The idea, though, is to kind of declare what data types are coming through in here. The state value itself was an integer, so I'm going to go ahead and put that in as int. The label itself was a string. The time itself was an integer. The video data, notice that it is a dictionary value, which means that I'll just come in here and say YouTube video data and put this in as a base model as well. And then I'll put the title in here also as a string. And so that's going to now be our data type in there, just like that. And then I also want to have something like is ready. And this was a Boolean value, as in true or false. Great. So here is the base data models that are coming through. Now, we probably want to have some optional data in here, and we probably want to modify things a little bit. But for now, I'm just going to leave it just like this. Normally, what I would end up doing is I would change this from snake case to, or rather from camelCase to snake case. So this is actually camelCase, and we want to change it to snake case. So eventually we will do that. But for now, I'm going to just leave it in the original form that we had it in. Next up, what we want to do is we want to come in from FastAPI. We're going to go ahead and import the API router class so that we can come in and declare our router as an API router. This allows me to then declare our API endpoint. So I can go ahead and do router dot, and then the HTTP method we want to use, like the post method or the get method. In our case, we're going to use the post method here, and I'm going to put it at the root of the route that we're building out. So I'm going to do that in just a second. So then we're going to go ahead and define the create video event. We're going to just name the function itself, and we're going to expect a payload of data that follows the YouTube player state data type. And then we're going to go ahead and just print out that payload of data, and then we're going to return back that payload of data itself. So the thing is, whenever you're doing Pydantic models, to actually get the dictionary in Python, it's actually going to be something a little bit more like this, where its data is payload.model dump. And that's it. So that model dump will then be a Python dictionary that will dump out this data, as we'll see in just a moment when we print it out. So the next step here is actually using this router inside of our main application here. And so if we actually take a look at our Docker app, everything should still be running, even though it's detecting changes and all that. So what I want to do is include the router. The reason I actually left this router in here like this is so it's going to be really easy for us to include it. So I'm going to go ahead and do from api.videoEvents.routing, I'm going to import the router as my video events router, just like that. So the router class that I'm importing here, or the actual variable, is this one right here. It just happens to be in the routing module, which we can see just like that. So that's how the imports are going. And then I can now include this router in here just like this. And of course I can have it at API/events, or I can have it at video events. And with that trailing slash in routing.py right here, that means it's going to be at /API/video events like that. Great. Okay, so with this in mind, I'm going to go ahead and grab this API endpoint and recall back to what our actual URL is. The open URL was at, well, it's going to be maybe a little tricky to figure this out right here. So I'm just going to go in compose.yaml. I see that the port that I'm using locally is 8002 as well as internally. So that means then going back into my Next.js application, I can go back into where I'm actually calling these events, which was this right here. We've got localhost. This should be 8002 now. And then of course it's going to be /API video events. I changed it to video events, slight change, not that big of a deal. So this is now going to be our FastAPI endpoint, and that's what we'll call it. And then down here, instead of it being our temp, we'll call it that. Okay, so now it's just a matter of testing if these things work. I think we'll still have an issue, and it has to do with something called cores. But at the very least, we can try it out right now without cores being in place. Okay, so let's just make sure everything's running. My Node.js app is still running, and then my Docker app is also running. We can verify this again by opening up our Node.js app just to make sure that that's showing up, and then open up our FastAPI app, which is also showing up at 8002. And then if I were to go to API/video events, that actual endpoint, I should get detail not found because I don't actually support that method there. So let's go ahead and see if I can add in that method just for a get and hello world. So get video event. This is not going to have any sort of payload whatsoever. Instead, I'm just going to return back a dictionary that says hello world just to make sure that we are hopefully on the right track. So I'm going to go ahead and save that, and then we'll refresh in here. I'm still getting an invalid one. So we've got API video events. Let's go ahead and try that again. Still saying detail not found. Let's go into main.py. Let's make sure we save that one. That could have been the issue. Let's go ahead and refresh in here. Now it's showing us hello world. Great. So what I was really testing here is just to make sure that that router was working. It should have been working even without this. So if I comment this out, what I should get is a method not allowed, not that it wasn't found. That's all I was looking for there. But now that I have it back in there, everything was saved. It is now showing that hello world. This hello world we simply don't need. So I'm going to go ahead and get rid of that altogether. I really just wanted to see and make sure that it was actually working correctly. Okay, so with this in place, I'm now going to go back into my Next.js app, and I'm going to look in the console here, and we want to see if this ends up working. So I'm going to go ahead and play it and pause it. Now we see that it has been blocked by a CORS policy. So CORS is cross-origin request security. So basically, you can't just send a post request to another website. There's security in place that prevents that from happening. We, on our local machine, are going to allow for it to happen because we really want to test out this data coming through. When we go into production, there's a lot of different ways on how we can approach solving that. That's not something we need to worry about at this point. What we really need to worry about is getting cores inside of our FastAPI application so we can actually see this data come through. Let's take a look. Let's go ahead and add in cores, so the cross-origin resource sharing. Of course, if you look in the documentation, you will see there's a number of steps involved to make this happen, but it's pretty straightforward, as you can see right here. So we're going to go ahead and just copy this out. This should help solve some of the issues we had with getting the data. So grab that one, and then I'm going to go ahead and grab these as well and put them right underneath the FastAPI stuff. So the origins themselves, what I often do with these is I use them as environment variables. But since we're testing things out, I'm going to use them as is. Now, of course, we don't need this domain right here. We really just need localhost. What the documentation says is these are two different origins. There is something for regular expressions, but these are basically treated as different origins because there's a different port. This port would default to port 80 because that's the standard HTTP port. If it was HTTPS, it would be 443. So the idea here then is we want to have the different origin based off of the ports that we're allowing. Our Next.js application is running at port 8000, but we also might want to support localhost. We also might want to support the HTTPS version of localhost 3000. It really depends on how you build out your site. But the point here is we now have these origins in there. Now, sometimes you might see where somebody just puts a star here. This is actually great for testing because it allows everything to come in. But let's go ahead and actually use it where we are being a little bit more explicit with the origin itself. So we have all of these local hosts. So hopefully what this did was solve our post request issue that we're having on our Next.js project, right? So if we look in here, let's just make sure everything's running. And let's go ahead and do a quick video play here. And we'll go ahead and inspect the element and see what's going on. So we get now a 422, right? So we're getting a different problem that's coming through in here related to this unprocessable content. So let's actually go back into our Next.js application then, right in here, and let's see what's going on with this problem right here. So what I'm going to do is console log, and we're going to go ahead and do await. And this is going to be the response.text. So we want to see what that error is. And that's what's going to allow for it. We might be able to do response.json here, but text is like an easier way just to make sure that it's coming through. So what that means is then, of course, we're going to jump back into our web application. We're going to refresh in here. We're going to go ahead and hit play, pause it real quick, and we should see that here is the error that's coming through. It's saying that it should be a valid integer, but it got a number with a fractional part, otherwise known as a float or a decimal, but this case is a float. So we're going to go ahead and jump back into our backend, our FastAPI application, and to our routing, and we want to change how this works. So the only thing that could probably be a float are this one or this one. So in other words, what we can do here is we can actually declare float pipe int. This means float or integer, which is actually really nice. So float or integer. We can do that for all of those, and this should actually solve that issue for us now. So if I refresh in here, let's just go ahead and reload the page, and then we'll run this again. Now we're getting something else. It looks like it's going through just fine. I don't have any errors coming through, at least from my backend. We got some related to something that's in the video itself, but now we've got this coming through. So let's go ahead and take a look at cursor and back into our API service here with FastAPI, and we should see all of that data being printed. This is great. One of the things that's missing though, that might be very clear or maybe not, is the actual video ID. It's not actually coming through in here. So I think I mentioned at the very end that we added this part right here. But of course, our actual serializer, the base model Pydantic, doesn't have that data in there. So what we can do is we can just go ahead and say video ID, and that's an str value that would come through. As soon as I save that, what we'll see very soon is that actual value coming through. There it is right there. So the nice thing about these models is it just ignores extra data. It doesn't invalidate it. It just ignores it altogether. If it's not one of these keys in here, then it'll just be like, okay, well, we don't really care because it's not in there. But do keep in mind that the casing does make a difference. So like, let's say for instance, is ready. If I were to change it to underscores, let's go ahead and take a look at if that data is coming through. We're getting unprocessable content. It's not even working in that case. So let's bring it back as is ready. And what I will do is I'll add in one more step, which is from typing. We are going to go ahead and import the optional class. Optional, there we go. And then I'll go ahead and just say optional and wrap that around the Boolean value. And I'll set a default to being false. Now I'll go ahead and say is ready as underscores. And now we can see the default is coming through in there. If I leave it out, I don't know if it'll actually work well without a default in there, and no, it doesn't. Okay, so we're gonna go ahead and say it's equal to none. Let's put that as our default in there, and there we go. So we see that this value is still incorrect. So the actual casing, whether it's camel casing or underscores, is really important for this one, which I'm gonna leave just as is. We'll have to come back to that in the very near future. But the point of this is being able to have all of that coming through. Now there's one more aspect of this that I want to come through now that I have cores in here. I want to see the origin that's actually sending this, right? So especially in cores, if I were to do something like this where it's everything, I want to know what URL is actually sending the request. I'll probably want to save that at some point as well. But for now, I'm going to go ahead and bring it into the actual view itself for this API endpoint. We're going to go ahead and bring in the request class here, and we can actually grab the request by arbitrarily adding in the request object itself, just like that. And we can actually print out the origin for it by, let's go ahead and say the headers equals to request.headers, and then the refer equals to headers.get refer. And I think refer only has one R for some reason. Okay, so let's go ahead and print out one R in the middle, that is. Let's go ahead and see if that's the case, and sure enough it is. Let's go ahead and change it to 2 R's, and we should see that it gives us none. Okay, great. So there we go. We've got our data and our refer. If I save it correctly, I will see the data coming through and the local host. So we are seeing all this data come through, and it's just going to continue at that. The reason this is, of course, is we don't actually stop sending the data. It's just going to keep going. So it's basically like, hey, this user has this page still active. They haven't left it yet. As soon as you were to leave that page, then the data is going to stop. And this would be a little bit more clear if we put a timestamp or something like that in here so we can actually see what's going on. But the idea is as soon as we go back into the video and start playing it again, then we start getting that data again. So it's kind of like allowing us to see what's happening with the user data. So we're getting really close to being able to fully associate a user session with what they're watching. There's of course a few things that we're missing here. One big one is actually storing this data. Secrets and environment variables are something you're going to continuously have to kind of adjust your approach on how you use it. So one of the reasons I like Docker Compose is that it will inject those environment variables for you, so you don't need an additional package to just use them. So in the case of main.py, for example, we can come in here and we can say import OS, and then I can do something like this where I say host equals to os.environ.get and host. And then we can go ahead and do something like host scheme, and we'll do something like os.environ.get and host scheme, and then maybe something like host port as well, right? And so this would allow for us to have some sort of origin based off of these things, right? So then our host origin would be basically those all as string substitutions. So the scheme in here, and then you could go ahead and bring in the host in here, and then the port, right? And then you could also do it where it's not necessarily with that port as well. So host origin, and then let's say port lists, right? So this would allow for me to do something like this then, where it's giving me the ability to have the origins coming from environment variables. But this of course requires me to actually set them, because right now they're just simply not set. And so realistically, what I would have to do is something like this, where it's just an empty value. And then we would come in here and then we'd say if all, and then we would want to put all of those things in here. So let me just add those in just a second, where we put them all in as a list in here, so that we are actually setting the origins correctly and getting ready for production, if you will. Okay, so this allows us to do all sorts of things by injecting those environment variables. So the real question here is, how do we actually set these outside of our code? And of course, I already mentioned it, Docker Compose is going to help us load it in. Now, a lot of times when it comes to a Python application, I will say, hey, go ahead and use Python decouple, because then you can have a fallback. You can use something more like config, and then having a default value in here of something that you might want to have. That's super nice. But of course, os.environ.get does have a default value, and you could do something like that. That is also an option there as well. But I like using Python decouple if I'm not using Docker Compose, or I like using both of them. I'll leave that up to you on how you go about doing this. But in this case, I now have the ability or the need to come in here and do something like host being local host, then the port, or rather the host port, is going to be whatever host port we want to allow for. And then we can also do the host scheme. And in this case, it's going to be HTTP, right? So we could also have a secure scheme as well. So if we can do scheme like Redux or HTTPS or something like that, you could also put that in there as well. And then you'd come back into your main.py, and then you could do these like optional scheme in here as well. But what this should hopefully do is solve this problem. Now, of course, using Docker Compose watch, this will also allow for it to actually load through, and we should be getting that same post. Actually, the data is still coming through because I never changed what I was doing on the front end. This is much more about those environment variables. But of course, we can also print out the origin or the list of origins that we have here now. Let me just go ahead and save that, and we should see those two origins coming through. Everything's looking good because the environment variables are actually working and they reload immediately. So oftentimes what I would say is you could just come in from decouple and you can import config, and then this actually changes it slightly. So if I come in here and do config, config, and config, and we put in a, something like cast as to an str, you could put a default value in here as well so that it doesn't run any errors. You could do exactly this. There you go. So now we've got this whole thing as well, and that should still give us those exact same origins in there. And the only reason that that works is because in requirements.txt, I added it. The biggest caveat here, though, would be when we go to run this outside of Docker Compose and just using this .env file, that's what this is going to load by default. So pick and choose how you want. I'm going to leave it in as os.environ because it's a little bit more simple and it's built into Python itself. Doesn't have any third-party dependencies. So that's kind of where I'm leaving it. But environment variables themselves are one of those things that are a little tricky because the way the best practices change all of the time, because also this .env.compose is going to be added to my Git repo, which means that I'm exposing these files where the .env file is not, right? So realistically, on my local environment, I might want to just have .env in there with the actual values themselves. But to keep things the most simple for the most of us, I'm going to leave this in as .env.compose, and then in my main.py, I'll leave it in as os.environ. Of course, you can change it later if you want. When it comes to storing data, we need to make a final decision on the casing for the fields or the column names. So the idea here is, are we going to pick SnakeCase or camelCase? Now, SnakeCase is what's recommended by Python. It's also often recommended in SQL. So for that reason, we're going to be using SnakeCase itself. But the thing is, technically speaking, you can use either casing. It will still work. So if you skipped a step or just don't agree with it, feel free to use whatever casing you want to use. I highly recommend using snake casing for the reasons I just mentioned. But the idea here is I want to show you how you can modify our incoming data to be snake case right out of the gates. So the way you do this inside of Pydantic is you change the field itself to have an alias equal to what the incoming data is going to be. In this case, it's the snake case version, or rather the camelCase version, and then we want to actually have it come in as the snake case version. So as soon as I were to save that, what I should see, assuming our video is still playing itself, we can double check that, and that's not at all the video we were trying to play. Let's go ahead and try that. And there's that data coming through as camelCase, and then on our back end, it is now SnakeCase. Great. So of course we could start to fill out this player state to be all SnakeCase on the back end, but realistically our front end should be the thing that changes. Our front end should actually come in as SnakeCase. So that's what I'm going to do now, and it's really straightforward on how we do that. First off, we set the default state itself to use SnakeCase itself as well. So come in here, and you have to do painstakingly every single one. Now, the reason I didn't do this before was so that we can have a discussion about it and we can come back. Because typically speaking, in JavaScript, you would use camelCase. That's how JavaScript recommends all across the board. So really for us, we don't need to change anything else to SnakeCase, just the data we're going to end up using. And that's really the key here. And so what we want also is, of course, handling the state change itself. We want to make sure that those things are all in SnakeCase also, and it's only going to be the state data itself, and it's going to be very, very specific, right? And here we go. Great. So that's how we can change it inside of the use player hook. But then, of course, on the page itself, before I sent the data, I could actually modify it all right here as well. I could create a function that just says convert to SnakeCase and then go through that. But really, I want to log out the data I'm going to send. I think it's a little bit easier to diagnose when we do that. But of course, now if I were to play this data, I should get errors probably from the back end because, well, I don't actually have the correct casing anymore on the back end. So let's go ahead and update that as well to being all in SnakeCase itself. And then I don't have to use that field here to make those changes. I don't need those aliases anymore because of the fact that we're changing this. Now, while we're on this, I also might want to say, okay, well, what data type am I going to commit to for current time and the state value? So when it comes to current time, I probably want to have those decimal places. So I'm going to go ahead and leave it in as a float. And then the actual state value, I think it's only going to be integers in there. So we'll leave it in as integers, and we'll see if that ends up solving it for us. As soon as we make those changes, we can see now all of this stuff coming through. Now, one other thing that we might want to consider here at this time would be, do we actually want all of this other video data as like a nested amount, or do we want to have something like video title and literally just have that, not have nested data. To simplify things, I'm going to go ahead and just leave in the video title and have it just like that. So that also means that if we come back into our front end itself, we want to adjust that a little bit so that it's not actually that sub data. Of course, if you did have that sub data, feel free to do it. So we'll go ahead and do video title here and just do video data.title. It's again, just about simplifying the data that's coming through, not so much of what you can do. Oops, let's change this right here. There we go. And then I'll come back up here and we will go ahead and use video title as an empty string. You could probably still leave that other dictionary in there if you wanted to bring that in. But again, I want to keep things as simple as possible for us so that in the future, when we go to do this, it should work just fine. So let's go ahead and replay this again. I'm going to go ahead and hit play here and we will see it looks like the data is all coming through. And then on my back end, let's go ahead and look at that and take a look at the data here. I still have my video title, my ID, and all of that. So all of the data that I'm gonna store is in this one single base model, which could then be in a one single table instead of trying to worry about organizing all sorts of tables. Because when it comes to analytics data like this, we can always merge data later. That's the thing here. It's like we probably don't need to merge too much data up front. We just need the raw data. The real key is going to be the video ID and then like the current time. That's pretty much it. We probably don't need any of the other data in there for all of the events. The other data in there is just kind of nice to have. There is still the session that we need to keep track of, but we'll do that once we get to the point where this data is saved. So let's take a look at how we can do that right now. We're now going to convert our Pydantic base model into a SQL model. SQL model is how we're going to define our database tables. It's going to be how we define our database schema. Now, the data types when it comes to database schemas are really important because of how we can do complex queries. So we'll talk about that more in a little bit, but the idea is we want to think through all of these really well so that later on the database side, we can do really complex calculations and the database will handle that for us. So we don't have to do a bunch of stuff in Python or in JavaScript, not all the time. Sometimes we might want to, but a lot of times we won't. Picking those data types early on is a key part of making sure we get that right, which is why we see stuff like typing and Pydantic itself. So the idea here is we want to change this to being a SQL model. Initially, I'm just going to have it as a SQL model that's not quite a table yet. Then we'll make it a table very soon. So the idea here is we come in and we do from SQL model. We're going to import this SQL model class, and then we'll go ahead and replace this base model here. And we're going to go ahead and save it just like that. I'm also going to go ahead and say table equals to false. We'll start off with table being false. We will change it in the very near future. But the idea here is I didn't really change anything else. So if I save this, and then I make sure that my front end is still running, and then I'm going to go ahead and jump back into the front end and just go ahead and play something here. And then we'll go ahead and see on the back end that, hey, sure enough, it is still going. So why is this still working basically the same? That has everything to do with the fact that SQL model is based off of Pydantic. So it basically works the same way. Now, one of the other parts about this is we can start declaring SQL model fields, which of course has a little bit of a conflict with Pydantic. So I'm going to go ahead and comment Pydantic out altogether. Now what we can do is stuff like, is ready, field index being true, right? Maybe we want to make an index for whether or not it's ready, or better yet, we would probably want to make an index for the video ID. I'm actually not sure if the is ready field is necessary because more than likely we're not going to be getting this data whether or not it is ready. We might sometimes, but realistically, the way our front end works, it just doesn't have that at all. So maybe that's something I'll remove in the near future. But the idea here is we can now declare things about our SQL model like a field where it will actually store data in a specific way. Now, another thing that we would probably want to do in here is have an integer, so an ID that's an integer, which will be a field of primary key as well, which we would set as true. And so if we look at it now, will we have any errors? At this point, we do. So the actual table that we'll end up having will look like this, but the incoming payload, which we would change just slightly so that we don't have this right here at all, because the table will create that for us. We would do YouTube player state create, or better yet, we just use this as YouTube player state, and then this would be something like YouTube watch event. So it's just slightly different than the incoming payload, which is this, of course, and then the watch event, the things that we actually want to store, might be the exact same. It might be a little bit different. In this case, they are the exact same. And of course, this watch event here, we would probably want to change it to being true. So what we could do is we could obviously leave all of this stuff right inside of routing.py. I don't recommend it. I recommend coming in here and doing models.py so that we can actually move things over in there. I use models.py because I'm like using a Django, mindset here in many ways. But of course, you could also call this something like schemas.py. I like calling it models because we are using SQLModel as well. So a lot of reasons to call it that. But you can call it whatever you like. That's one of the beauties of using something like FastAPI is you have a lot of flexibility. And of course, you could leave it into routing itself. I just don't like doing that because it starts to make the router a little bit too much stuff going on. So I'm going to go ahead and go in here and say from .models, we're going to go ahead and import the YouTube player state. And then I'll go ahead and get rid of some of these imports that are in here that we no longer need. So now it's very, very focused. And then models themselves are also very, very focused. We don't need the API router in here. So we now have basically just very focused data on what it should be done. Okay, so now of course we need to bring in a database table, a database itself, and then store this data in those database tables. We need to do something called migration. Let's take a look. We're now going to integrate a Postgres database. Now, the way we're going to do this is through compose.yaml. I actually already have a database up here, and that is the TimescaleDB one. But I'm going to go ahead and use Postgres itself and just show you how you could just use raw Postgres if you want to. So let's go ahead and do a quick search for Postgres on hub.docker.com, and you'll see the official one in here. There it is. Go into tags in there, and then you're going to want to get the version you're going to use. In our case, we're using Postgres 17, so I'm just going to do a quick search for 17, which I think would probably be the latest one anyway, but we'll go ahead and do 17.4 just so you see how it's all done. So the idea here is you just grab whatever this value is, and then that's going to be your image. So I'll go ahead and do it like this, where it's just like that. I'll comment the DB service out. We'll save everything and close it. Then I'm going to go back into Docker. I'm going to hit Control C, bring it on all down so that we can then bring it on all back. So Docker compose down -V. This will delete the volume as well, as you can see. So any of our database data would be gone right now. This, of course, is really important to understand when you're working locally. When you go into production, that can still happen if you're using Docker Compose or if you have other things that are automated, but it's a lot less likely to happen on accident. You would have to be very purposefully doing it. This is very purposefully doing it, of course, but this is a very common, command to run. So it's very common that you might accidentally delete all that stuff. But now that we've got a new database here, it's going to be pulling the database service. It wasn't ready because, well, I used a different database engine initially. But with that, I don't actually have to change anything else. This is the beauty of using something like Timescale, is we now have Postgres already ready to go. Of course, I could still use TimescaleDB the same way. I don't actually have to change it. I'm just doing this for educational purposes. That's it. So now that we've got a Postgres database up and running, we see that I've got a few things already set: the username, password, and database name itself. Those things are in the database connection string right here. Luckily for us, SQLModel can work off of these connection strings. Every once in a while, you'll see it where that plus psycopg is not in there. It'll just be something like this or even like this. When it comes to using specifically SQLModel, using plus psycopg makes a big difference because that psycopg is a requirement that our SQLModel is using, which is down here, right? It's quite literally for Python itself. Okay, so with that in mind, we now have the ability to, connect our FastAPI application. So inside of the API here, we're going to go ahead and create DB. Inside of DB, we'll go ahead and do the init file, so the dunder init dunder.py, and then we'll also go ahead and create session.py. Now, this is where we're going to define a bunch of stuff. Now, the actual code that we can use for this is actually pretty straightforward. First and foremost, I'm going to do a few imports here. I'm just going to copy and paste them. But the idea is we grab the database URL itself, and then we grab some things related to SQLModel. The first thing that we need to set, assuming that the database is actually implemented, will be the engine that we're using, which is where SQLModel comes in, and we do something like create engine for this database URL. right? And so this engine itself will be used in our database sessions, as we'll see in just a moment. After we do that, we're also going to create a function called initDB, and then we're going to call SQLModel.metadata.create all of that engine. So this is going to create our database tables, and it does it one time. Well, it will do it one time once we correctly implement it. The idea here is this will not do database migrations, as in if you need to change the database table in the future, this standard one right here won't actually do the migrations for you, won't do the changes for you. There's something called a limbic that can allow for that to happen. But in our case, that's why we really want to spend some time thinking about what we're going to end up storing in our database, because we don't want to change it that often, especially with analytics stuff. Maybe in the future you might want to add something, but as far as changing the actual database tables, that's not something we're going to cover at this time. If you want to see that, please let me know in the description. But the idea here is we will have our init database function that we now can bring into main.py. So inside of main.py, we'll go ahead and bring that one in with from api.db.session. We're going to go ahead and import that initDB. And as you may recall, when we actually brought in main.py, we did have a function called initDB already, and we're going to go ahead and bring that back in. It needs to be in this lifespan async context manager to actually run correctly. Now, of course, we could also verify this by printing out something like, creating DB, save that, and then what you'll see is it actually runs that all together. So this is actually not going to be super obvious that it did work correctly until we actually start storing our data. So that's something we will do very soon. But before we get to the storing of the data, what we're going to do is we're going to create another function called getSession. This function itself will use the SQLModel session. So we'll do with session from the engine itself as the session, and then it will yield out the session. I should spell session correctly, and there we go. So this is to be used within routes or API endpoints. Okay, so we're going to go ahead and use this now in any given route. So down in here in our create video event, this is where we're going to want to do it. So I'll go ahead and do from api.db.session. We'll import get session here. And then inside of FastAPI, we're going to go ahead and bring in depends. And then from SQLModel, we're going to go ahead and import the get, or rather not depends, but rather import the session class itself again. So now down inside of our API endpoint here, we're going to go ahead and bring in our database session as one of the last things. We'll call it the session itself. We could think of it as the DB session, right? That's totally fine. Either way, just to make it a little bit easier, it's going to be of type session from SQLModel, and then it's going to equal to depends on the get session function itself. And then that way we can actually do things related to this session, which of course we will do very soon. But right now, we just wanted to make sure that this is in there and it is working. I don't know if printing the session is going to do a whole lot, but we could totally do that if we wanted to. Let's go ahead and give it a shot with a video playing. Let's go ahead and hit play here, and let's see if that does anything. And I'll scroll on down, and there we go. So that there is my SQLModel ORM session that is ready to roll and ready to do whatever's next. Let's store some data to Postgres using SQLModel. First thing that we need to do is jump into our models and change this into an actual table. Then we're going to go ahead and import this into our routing if you don't already have it imported. Let's go ahead and do that right now. Now do keep in mind the YouTube player state, this is going to be our validation model. The actual database model does not need to be validated in addition. So we can just use just that. So what I'm going to do here is I'm going to say obj as an object is going to take in the data that is being dumped by the actual, YouTube player state model dump, the actual validation model, this right here. Table false has to stay that way. Otherwise, we'll have maybe issues potentially. It doesn't have to stay that way, but it is a good idea. And also it could have stayed as a Pydantic model. It doesn't actually need to be a SQL model. So you could also change that as well. But the idea here is we now have this object here. So all we need to do is add it to our session. So db_session.add that object. then we do db_session.commit. This stores it into the database. Now, since we actually have an ID here, we're going to take a look at this object in just a moment. So I'm going to go ahead and print out the object itself. I'm going to get rid of the data and refer print statements for a moment, as well as the DB session. Okay, great. So let's go ahead and save that, and then let's take a look. Assuming everything is still running, and I think it is, we're going to go back into our project here. Let's go ahead and take a look at one of the videos. I have this one right here, and I'll go ahead and hit play. Looks like I don't have any errors here, which is great. I do have this DB data thing coming through because I did actually make sure that we get that response data in here as well, just to verify that that's coming back. So if we look back into our backend, what we should see is the data as well. So the object itself looks like it's not necessarily showing me anything inside of here. So let's go ahead and return back our object here and see what happens now. So I'm going to go ahead and come back into the actual web page here, and we'll refresh, hit play, and now we're getting nothing in our DB data. Okay, so it seems like it's adding the data, but it also seems like it's not doing anything. So let's actually see what's going on here by doing db session.refresh of that object and see if that changes anything with our data. And so if I refresh in here now, hit play, now I get the data coming back. So realistically, I just need to update this object. I need to refresh the object to be able to see the actual data coming through right in line. Otherwise, it just won't show up. And so now what we've got here is that data coming through. Another reason to refresh is this ID in here. Notice that it is adding in an ID for us. And that's a big part of the reason why we actually have that field, is to make sure that it's auto incrementing, which Postgres will do by default. It's automatically setting that for us. Now, if we did want to use this as our validation, the ID itself would need to be optional. So we would have to come in here and do something like optional of that field. But then it runs into other issues that you might want to have. In other words, what I'm saying here is you want to make sure that the incoming data is validated with its own specific model, and then the routing itself will just use that validation. But we do see, of course, that the refer is not coming in. So let's go ahead and add in the refer to our data. We can do it right here like this and set it something along those lines. Or of course, we could also do something along the lines of refer equals to refer. And I think we should also be able to do obj.refer equals to refer. So a lot of different ways on how we can set that refer, which also means that in my model, I want to set that one as well. So we'll go ahead and do refer equals to, this will be a, let's say an optional string, and the default is going to just be a field with the default being 0, and or empty string, not 0. And then we'll also have this as an index value, because you might want to, search by the refer that's coming in and refer like that. Okay, great. So now that we've got that, I added a new model here. So of course, what we need to do is actually take down our database. Otherwise, it's just simply not going to work. We're going to see this programming error because it simply is not there. So going back into the root of our project, I'll go ahead and just do docker compose down -v. This of course takes everything down for us. And then of course we can bring it right back up in that other session, in which case it will now have that database table, because again, we don't have anything to do the migrations. This is where you want to think through all of this stuff as soon as possible so that you can make sure that it is storing correctly. So let me go ahead and refresh on here. We might have a moment before it actually saves or gets everything up and going. So let's go ahead and see if it is working. Looks like we had an issue with our app. It failed because the database wasn't ready yet, but now it is ready. We can refresh in here and we should be able to see all of the events that are coming through. We can pause that and we can also take a look at the referrer coming through in there, and that's also showing up, which is great. So it's giving us all of the data we want. The other part about this on our back end within our routing, we can also have that as our response model. So every once in a while, if you want to have a different response model, you might do that. So something like this. So that would be the default response model that we were setting without me specifying it. Now, if I were to specify it, we can go back into our models here and we can go ahead and say something along the lines of our YouTube watch event response model being as verbose as possible. Perhaps we have the ID, the video ID, and maybe the current time. Maybe we don't want anything other than that, and that's literally what we respond back with, in which case we would change this to not being a model or a table itself. We would grab that, we'd bring it into routing, and that's what we would bring in, which then narrows what we return back to our front end, which we can verify by going back into our front end, refreshing here, and now we can see the data that's coming through in here, and it's only very specific data. It's a very small amount of data. So that's how we're going to store the data and respond with it from a SQL model into Postgres. Now, of course, we could use Postgres going forward and it would probably perform pretty well. But the thing is, once you start getting a lot of data in there, Postgres really starts to not perform as well, which traditionally speaking, then it would be like, hey, you should probably use a different database altogether for massive amounts of data. We are not going to use a different database. We are going to be using something that's built on top of Postgres, the TimescaleDB extension. That's what we're going to be using now. Let's take a look. Now we're going to use time series optimized Postgres with TimescaleDB. We're going to go ahead and take a look at Docker Hub and just do a quick search for timescale. Of course, if you look there, you'll find timescale/timescaledb. And in which case, if we look at our different tags, we could go through this process. The overview also shows us the latest releases in here. I'm going to be using Postgres 17 optimized and activated for time series data, and of course the timescale extension, which of course I already have in my Docker Compose. As soon as I do that, I need to do Docker Compose -v. This of course is going to delete all of the data and then allow for me to use a different version of Postgres basically, in which case I will go ahead and bring this up, which might take a moment or so depending on if you have Timescale already downloaded and all of that. So all I really need to do now is use the TimescaleDB package that I actually created. So if you actually go to GitHub and look for the TimescaleDB Python package, this of course will be linked in the description as well. Hey, give me a star if you really like this. But the idea is we install it with pip install TimescaleDB, take a look inside of our requirements, and what we've got here is TimescaleDB package right there. Now, there's a couple of ways on how you could do it. You could do it manually based off of what we just did. So you could always take the actual SQL model and just work off of that and then add some options and then run inside of the initDB method. You could run a bunch of things related to it, creating a hypertable and all of that. Or you could do it automatically, which is what I recommend that you do, which is basically just changing your SQL model into a timescale model and then adding a few configuration items in there. So what we want to do then is jump into our models here. We're going to go ahead and import. So we'll go ahead and do from TimescaleDB. We're going to import the timescale model, and then our YouTube watch event is now just going to be that timescale model. I no longer need to have the ID in here because if I take a look at the timescale model itself, it already has an ID. Notice that it is optional. I did mention that that would be the case. There's also a few other configuration items in here that I just didn't do in my model, but it is well worth doing. A new field that's going to be in here is the time field. This field is a requirement for hypertables. Hypertables are the time series optimized tables that go into different chunks. Those chunks are going to be based off of the configuration you do, what we have right here. So I'm actually going to go based off of the one that I've got in my documentation here. I'm just going to go ahead and copy this. We're going to jump back into our model and we're going to go ahead and paste these in here. So basically we're going to make a chunk time interval of 7 days. That's probably plenty. We're going to drop after 1 year, as in this data is going to go away after 1 year. Now, we could of course back up this data if we need to, but by default, to make this as optimized as possible, it will actually go away after a year. You could make it a shorter interval as well, but overall, that's what we're going to do. And then we want to do the compressed segment by no longer sensor ID, but rather the video ID itself. So basically some sort of unique value that's in here that's not related to the time itself, more like the sensor ID in this case, right? So if you think of the videos, that's going to be the specific thing. The actual data about that video will change over time. But these are going to be basically the intervals that we end up doing, all of the timescale configuration that we need. So this is our timescale, DB config. That's it. A lot of these things have defaults as well, as you can see inside of the definition itself. There are some defaults in there, so feel free to change those as you see fit if you need to. This I think is fine. This works well for us in terms of our chunking. The chunk time interval, we might want to bring it down a little bit depending on how much data we end up getting, but I think 7 days is a good start. You also might make it bigger if you aren't getting that much data. The nice thing about using timescale in general is it's really well optimized for all kinds of stuff. But of course, if you make this a too small of interval, it might affect your performance because it's quite literally chunking all of the data based off of that interval. Right now, the chunk is over 7 days. If you made it like 1 day or 1 hour, then you're gonna really kind of expect a ton of data coming through in that amount of time. So do keep that in mind when you go forward with this. Okay, so now that we've got this, I probably actually need to bring the database down again because I did make some changes to the models and all that. So go ahead and bring it down and then we'll bring it right back up in just a second. Okay, and so there it goes. And I'll save, models.py again just to make sure it reloads and it's running. Okay, so with this in mind, we now need to go to the next step, which of course is just using create all. So after we define our SQL model, we also want to run create all within our session. So back into our database session here, I'm going to go ahead and import the TimescaleDB package, and then right underneath the metadata create all, we'll go ahead and do TimescaleDB metadata create all engine. This will make sure that all of those hypertables are in place and are working correctly. And so that's pretty much it. That is now pretty optimized data in here. So one of the things that I want to do on my response model here is I'm going to go ahead and add in a time. And of course, the time itself is, I believe, a datetime object. So let's go ahead and just double check in the model itself. Going in there, we take a look, there is time. That's the field that we want to return back as to when this ended up happening. So we'll go ahead and use this one as our default time that we'll return back with. And so there we go. And then I'll also go ahead and grab that one in. So from date time, we're going to import date time. There we go. So now that response is close to being done, but there's one more thing that you maybe overlooked. I certainly almost did, which was the engine itself. We want to make sure that we're using a specific time zone. The SQLModel one does not have a specific time zone. This one does. So we're going to go ahead and grab that one now as well inside of our session. So from TimescaleDB, we're going to go ahead and import the create engine. The only reason I'm doing this import is because then it's just very obvious that it's not using SQLModel anymore. And then we're going to go ahead and set our time zone. I'm going to use the default of UTC. Now, I really like using that default regardless of where I am in the world, but there are things that we could do to optimize it as well. I'll just leave it as UTC for now, just to keep things simple. So once again, maybe I need to bring things down. I'm just going to go ahead and do it because I made a bunch of different changes to how we use the database. So just removing the database and then running it again, or more specifically, removing the data in there and running it again to make sure that it is working is going to end up being a pretty good one. Okay, cool. So now that we've got this, we've got our database and everything in there. I'm going to go back into my project here and we're going to go ahead and play this out. And what we should see is that time data coming through. So it is creating a timestamp for us and it's doing so at the interval that we set out. And of course, we can continue to add a bunch of data in here. And I would recommend that you do, because in the very near future, we're going to take a look at how we chunk this stuff out and how we'll be able to actually access this data based off of chunks and also grabbing and aggregating data over time, also based off of chunks. As it stands right now, our watch events don't really have much uniqueness beyond the actual video ID. We want some uniqueness related to who is watching it and maybe even where they're watching it. So the idea here is we want to jump back into our project and we want to make an actual model for our watch session. So I'm going to basically take the video events and I'm going to go ahead and duplicate it, and we're going to call this our watch sessions, something like that, right? And I could call it sessions itself, but I don't want it to be confused at all with SQLModel. So I'm going to call it watch sessions, both in terms of the directory that's holding it, but also the model itself. I'm going to go ahead and call this something like watch session. So what's the point of this? Really, it's to have a session that we can then tie into our watch events. So in other words, I'll come in here at the very bottom, I'll go ahead and do my watch session ID, and this is going to be a optional string as well, and it's going to have a field in here with an index being true. Okay, so why is it going to be optional? That has everything to do with just to make sure that if we don't have a session ID for some reason, but the video is still playing, we still want to capture that data. Then we know, hey, the watch session, something failed there. And we're totally okay with that because the actual analytics that we're trying to grab is really to help us inform how our videos are doing and which ones we should improve upon. This watch session thing is really just about collecting all of that data and making it a little bit more unique per person who's watching instead of unique per video or just unique per video. So back into our model here, I said the session ID is going to be an ID, or rather a string. So I'm going to go ahead and copy this and bring it on over here as well. Now, if we think about a watch session, there's a lot of things that we could potentially bring in here. Something like the path, as in where was this originally created? This could be an optional string. We could also do the refer, which is also, hey, where was this created? Obviously, I have a refer down here as well. So both things could absolutely be items that we might want to group these sessions by. Now, of course, you could also do other things like user time zone to see where they are located, potentially their IP address. You could absolutely add in a bunch of other things in here to enrich this data a lot. I'm just going to do these three to make things as simple for me as possible. So next up, what we've got in here is ready, Boolean, all this stuff I don't need. I probably don't even need the video ID unless it's going to be something about where it's created, the initial creation for that session. So maybe we also do that as well. And I'm going to go ahead and put that in also as an optional string. And we can still use that as an index as well, which is fine. Okay, so now that we've got that, I'm going to go ahead and get rid of these in here. And then we've got our TimescaleDB configuration. The main ones here is how we're going to consider our watch sessions themselves. Now, the way I'm going to approach it is I'm going to get rid of a few of these options and really just think about the chunking that we're doing here. When it comes to watch sessions, I won't have nearly as many watch sessions as I will have watch events. So I actually anticipate this to be more like 30 days, maybe even longer in terms of chunking this data of the different watch sessions. But the nice thing about 30 days is then we can have a chunk of the basically trailing 30 days, which I think is pretty nice. So you can kind of analyze it based off of that. And then as far as dropping it, I'm going to drop it after 3 years. So we can basically see sessions over time as to what's going on. Now, one of the things you might consider doing in here is having something like watch events count, like the number of video watch events count. You could potentially put it into the session itself so that when they're done with the session, you basically, kind of aggregate everything up into it. But that's not fully necessary. You don't need to duplicate the data because all the events are already stored in there. Great. So now that we've got this watch event here, I'm going to go ahead and create another one, which is basically going to be the watch session create. So I'll go ahead and do watch session create. And once again, it's going to be our timescale model, or rather we can actually call this our SQL model or a Pydantic model even. And the idea here is the create will have the path, video, and video ID, right? And so we can probably put it in here just like this, where the default values are coming in as empty strings basically, which I will do on all of them, just like this. Okay. So these are all optional things to create any given session. Then the actual session itself will come back with this session ID. But of course, I don't actually set this ID just yet. So I want to make sure that I am setting it. So going back into my timescale model, we do have a primary key already. And it's actually a composite primary key because it's using both the ID and the time to make up the actual primary key. But the idea here is we don't need to adjust our primary key whatsoever. We only really just need to have some uniqueness to the entry that's coming in here. That entry is going to be based off of something that we want to have. So in this case, I'm going to say something like generate session ID, or we could call it watch session ID, and I want to return back a string value. What is it that I'm going to use in here? Well, it's going to be it's going to end up being an STR, and it's not going to be optional. I definitely want to make sure that this is happening. So the way this works is you can actually, inside of the field, you can do this default factory argument that passes in a function. That function will then be called at that time when it's created, and we can actually use something like UUID and do UUID.UUID4 and create that UUID. So that gives us some uniqueness for the session that I can then share with the front end, which could then eventually share with the watch event. All of those things we will do very soon, but the idea here, of course, is now we have a way to create it and a way to retrieve it. So back into our routing.py, we have a lot of the same sort of stuff that we're doing with the create video event, but now, of course, it's going to change a little bit, and it's going to be our watch session and our watch session create. So the incoming payload is going to be this. The response model is going to be this. The data that's coming through, just like that. There we go. So the defaults should be empty strings and all that. Notice that I have a referrer in here. So maybe I actually don't want this on the create session. I can just have it in like that. That's also another option, or let's just double check. Yeah, so the headers are coming through for the referrer, not the actual payload itself. The path optional, of course. And there we go. Okay, so with this in mind, we now can actually create these sessions. I probably don't need to print things out and all that, but of course I want to call this something like create watch session. And there we go. So we've got our routing up. Next thing to do is go into our main.py, and then we'll go ahead and bring that one in. So from api.watchSessions.routing, we're going to import router as the watch sessions router. And then we'll go ahead and add this into our routing down here. And this time I'll go ahead and call this maybe watch sessions, and we will reorganize it. And there we go. Okay, so now that we've got this, let's go ahead and run our Docker Compose down, because a lot of the data is not in there any longer. So we'll go ahead and do Docker Compose down -v. This, of course, is because of migrations. We have no way to migrate the database tables at this point. Okay, cool. So one of the other things we might want to make sure that this table is equal to false. I think that default is that, but it is also nice to do that every once in a while as well. Okay, so now that we brought it down, I'm going to go ahead and bring it back up, and there we go. So now we should be able to create these sessions. We're now going to create our watch sessions with Next.js. Before I do, though, I want to jump into my FastAPI one and make sure my watch session router is actually being used. I accidentally left that out in that last part. So let's go ahead and jump into our Next.js application, more specifically in the watch page. Now, the reason I'm looking at this is because it does a lot of the things we will need to do with our actual session ID hook. So we're going to turn this into a hook itself, and we'll go little by little. Now, do keep in mind that the reason we are creating sessions is so that we can use the browser session storage. So we can basically temporarily create a session ID that then gets wiped when new sessions start in our browser, which we will see as well. This just helps us understand what's going on with any given session for like a new browser tab, if you will. Okay, so that's kind of the idea that we're going to work off of from here. So inside of our Next.js app, we're going to grab page.js under watch. We're going to put it into hooks here, and I'm going to rename it to being something like useWatchSession.jsx. So right off the bat, I want to change the function to being useWatchSession as well. So the idea here, of course, is we want it to be front end. So we're going to go ahead and do use client. This needs to be in the browser because we're going to use a few other things as well. Now, what we're not really going to do is stuff related to the YouTube player and the navigation itself. But what we will do is we will bring in the video ID like we saw in the update backend stuff. So we will update our callback here just a little bit. It's not going to need to be a whole lot. The next thing is I'm going to go ahead and get rid of all of this stuff in here, and we'll come back down into our update backend. This will just be called create session, and then we'll come down and we'll pass in our argument here with that video still. So it's still a part of this. Even if that video is not actually available, it's still a part of this. So this create session, we actually don't need the current player state at all. We pretty much just need the video ID. Now, we might need a user ID if we were using users. We could pass it in very similar to this, which is exactly why I have the video ID in the first place. It really sets you up for later if you need things to be a little bit more complex. So what we want to do in here, of course, is we've got our headers. That's fine. We've got our response. We're going to go ahead and fetch to the FastAPI endpoint, which of course is no longer this one, but rather something like our watch dash and sessions. I believe that's the endpoint we just looked at. Let's go ahead and double check API watch sessions. There's no trailing slash here, but of course, if we go into routing, there's that trailing slash, there's our watch session. Great. So that's correct. And it's post method. Again, we want to verify that. There's the post method there. And then we've got all of the data we want. This, we don't need the current player state. We pretty much only need the video ID. We probably don't even need that. We could probably send just empty data, but having the video ID is just one of those things that allows us to see all sorts of stuff. And so now we've got our create session method. This is fairly straightforward. Next up, what we need to do is just call it essentially. So initially, I'm just going to call it over and over and over again. So that's what we're going to see. Inside of the use effect, I'll go ahead and call that create session. And what I want to see here is this DB data. I'll call this my session data instead of DB data so it doesn't get conflicted with the other one. We no longer need the player state. Now I'm going to eventually return something other than some JSX, other than a actual, HTML element, basically. I'm going to go ahead and return back something for the moment. Okay, so here's our watch session. This is how we're going to create those sessions themselves. And of course, I don't have anything related to the actual session storage yet, but we will really soon. So with this in mind, I'm going to go ahead and bring it into my watch page now. And I want to put it right under the video ID so I can actually still grab that one. This is much more about where this session's created than anything else. It's not about correlating to the video ID at all, but knowing where the session starts and maybe what videos are watched as a result might be interesting information later. So what I want to do here is we'll go ahead and do something like session ID equals to our useWatchSession, and we're going to pass in that video ID. Obviously, I don't have a valid session ID yet, but we will go ahead and console log this out and just take a look at what that session ID is. And I'll go ahead and just say session ID just like that in my console log. Okay, so let's make sure everything's running, and sure enough it is. I'm gonna go into my Next.js app in here, and we'll go ahead and take a look at the console log. I just refreshed on that page, and then we see in here, we've got DB data is, and then we've got, well, we already have a bunch of IDs in here. So this is not the DB data is not what we're looking for. We wanna see our session data in here. So it looks like I'm not necessarily seeing any of our session data. Ah, there it is right up here. There's our session data, and we've got a watch session ID in here, just like that. Okay, great. So now I know that I can actually create the session data, and I have a starting video, I have a timestamp, I have an ID, I've got all sorts of things. Great. So now let's go ahead and see how we can use session storage for this. So first and foremost, back into our watch session, what we want here is to have some sort of session storage key. And this one, I'm going to just call it watch sessions. Now, I could call it something different, maybe a little bit more specific, so it's not that confusing, but maybe like watch session storage key or API watch session storage key, something like that, right? Make it as verbose as you need to. But the idea here is I want to go ahead and store some of my data. That data, I'm going to go ahead and use this console response here. We'll go ahead and use session storage, and then it's going to be set item, the key value we want to use, and then the actual data that's in there. So we're going to go ahead and use this key value, and I'm going to go ahead and do something like json.stringify of the actual response so we can actually see what that looks like. So we're saving that item in there just like that. Okay, so now down inside of my use effect, I want to actually take a look at that data. So we're going to go ahead and say our session response data. Let's call this our stored response data, or maybe our stored session data, stored watch session data. Just make it as verbose as you need to. This, of course, is going to be session storage.get item, and then it's going to be the same key itself. And then what we want to do here is we're going to probably need to load that data itself. But before I load it, I'm going to go ahead and just do console log of that session data, just so we can see what it is, and we'll save it as is. Okay, so back into our Next.js app, I'll refresh in here, and we see that if I refresh a couple times, we can see the data is right here. Okay, so of course, if I do it again, it's going to create a brand new one. We don't want to create a new session every single time. We actually want to use the one that's being stored. So that's what we're going to do in here. So now what I want to do is create a try block. So a try catch statement in here. We want to load this data. So I'm going to now say something along the lines of loaded watch session data, or maybe loaded watch session ID. And so the idea here is I want to set an actual ID, the value that's stored in that response data. Now, at this point, we might consider how we want to actually store the data. Do we want to store all of the session data? Maybe, maybe not. The reason I might consider storing all of the session data has to do with more than the video itself, but more about the actual timestamp. So maybe I do want to keep this timestamp and also the watch session ID, or maybe I just want the watch session ID itself. Let's take a look at how we could do it with the entire data set and then just change it a little bit so that it actually just does the ID. So the idea here then, it would be actually to load that. So we would actually say something like the loaded data. So I'll do const loaded data equals to JSON parse, and then we bring in this parse data. Of course, this loaded data is not quite what we're looking for. We're actually looking for the watch session ID. And then so now I can actually set the loaded watch session to that itself. And then we can basically just return back, essentially if that exists. We'll go ahead and say if that exists, then we'll just go ahead and return back. Well, maybe we can't return it here. We actually need to return it down here. So this brings in the next part, which we would actually go ahead and say something like use state. And then now down here, I'll go ahead and say const and session ID, set session ID equals to use state, and it's going to start off with null. So now in my use effect method here, we would basically just go ahead and say something along the lines of set session ID to the last watch session, and then we'll go ahead and return it. So this should actually be loaded watch session. If that even exists, then we'll return it. And what is it that we're returning? Well, we're actually exiting the use effect here. So what we need to do is come down here and we would return back the actual session ID down here. So this also means that in my callback method down here, after I store the session storage, I can also grab that same sort of data, and we can say something like the watch session ID equals to that response data. And once again, we'll go ahead and do set the session ID to that watch session ID like that. And so that should allow for me to actually return back that response data. The reason we have this is so we exit the use effect and we're not actually recreating the session itself. Great. So let's go ahead and save that and we'll take a look. I'm going to refresh in here, and now we've got a null session ID, and eventually it's the correct one. It's this one right here. If I refresh that page, it should be the exact same one. It's assuming that it's going to be the same session. Let's go ahead and actually close out the page. I'm going to copy the URL. We'll close out the page and we'll see if it's similar. I think it's ended with an F. We can verify that, but it should actually create a brand new session. If I have that session still open, let's go ahead and see what it does here. I'm going to go ahead and go into the console here. This one also creates a brand new session. So C5 and then D6. So yeah, we've got new sessions for new sessions, right? So a new tab happens, new session happens. And this is where actually having a robust database and something for time series can handle this super well, right? So eventually this data is going to go away, but it handles all of that data. So if you have a ton of sessions going on, well, we can track that now. We can track it very granularly. Whereas if I was doing this with just Postgres by itself, I would probably have to have one session for the whole thing. I'd probably have to use local session storage, but in this case, we can use as many sessions as we want and just use straight up session storage, which I think is actually pretty great. And then of course we can associate it even further if we actually had users authenticated, which is basically like the overarching session itself, which would have sessions within sessions, which is also pretty interesting. But the idea here now is now that we have this session, we'll be able to enrich all of the data where we see fit. So I'm going to go ahead and get rid of a lot of the console logs related to the session itself. Let's just go ahead and do that now, except for maybe the errors, in which case you would want to update and change as you see fit. So the idea here is going forward, if you didn't want to stringify the response, all you would do is something like this, set that item. Let's go ahead and bring it back up. I'll go ahead and do something more like where we set it here and we just set that data right in line. We don't need to stringify it or anything. And then down here, it would not be parse. It would just be using that actual data. That would be the loaded session ID. But I'm going to leave it in as that response data like that, and we'll leave it going forward just like that as well. And then of course on the actual backend here, if we wanted to limit the data that's coming back, we could do so within our routing. So the actual response model, maybe we change that so it doesn't have the session ID, for example. But that's not something I'm going to do at this time. It's just something that's well worth learning about. The actual stored database ID versus the session ID. That's what I mean. Okay, cool. So now that we've got these sessions IDs, it's time to actually enrich the other parts of our application to make sure that these session IDs are actually being used when we store our video data, so then we can start aggregating and analyzing some of that data. We now want to enrich our video watch event model with the session ID. This is going to be a fairly straightforward process, but we want to think through the best option here. Now, on one hand, the session ID itself could go in the body data, which would mean that our actual backend model, the actual schema that's coming through, we would modify to include the session ID. But the thing is, we might want to use the session ID a little bit more globally, as in other places. So realistically, we probably don't want to modify the body schema very often, but rather we want to actually get the header. We want to modify the header for it. So what I'm going to do is I'm going to call this the session ID, and it's going to be headers.get, and I'm going to call it x-session ID, and we want to just take a look at what that is. And so if I am going to enrich a header, I need to make sure that I'm passing it in the front end, right? So right now it should only print out nothing. So let's go ahead and just verify this. So what we will get is I'll go ahead and put in session ID, just like that, and then I'll put another print statement in here, hopefully to see a little bit more of the session ID. There it is right there. Okay, so we've got none coming through, although I am still getting data coming through because of how our events work. So how do we actually bring in that session ID? Well, of course, we have this update backend, and we can pass it in right here. So we can actually do something like x-session-ID and then pass in this session ID right here. But we have to remember, whenever we're using callback and we're using arguments that are required or dependencies of the actual function itself, in this case, this one is, we need to pass it into the dependency array as well. And so this is where, the camel casing and snake casing might make a difference. So I'm actually going to change this into being snake case as well, just to kind of fit better with what we've been doing with the video ID. But overall now I have this ability to pass this header. As soon as I do that, I'm able to go back into the backend, and I now can see that there is my session ID. So of course it works very similar to the referrer here, in which case I can actually come in here and do object dot, and let's actually just verify in our model what that object is, and that's watch session ID. So let's go ahead and call it that, and then we'll do watch session ID equals to that session ID that's coming through right there. So this is actually pretty nice, because then if we ever needed to change our headers, we could change the value of the header, but also the actual header. And also, if you wanted to use the session in other models, you won't need to post that data. Similar to like our referrer here, we don't need to post that data. It just comes in with our headers. The only idea here is our headers need to be correct. So one of the things that you also might consider here is making a single function that will actually do your API requests that you kind of use yourself. So in other words, you would say something like my fetch, and then you wouldn't have to pass in any headers because quote unquote my fetch would actually handle it for you. That's not something I'm going to do right now, but it is something well worth learning about and maybe potentially using if you're going to be doing that. The nice thing about using hooks, in this case, this right here, is it's a lot easier to use hooks in more places than just one. That's one of the reasons you use hooks, is for that. And it's very similar to this update backend. This update backend function pretty much only works on this one single page, whereas the useWatchSession and useYouTubePlayer can work in other pages as well. You don't necessarily have to update the backend, although this could also be its own hook as well. But with this in mind, we now have a way to send the data back. All we need to do is start actually aggregating the data out. Now that we have the session ID and then our model itself is being set with that session ID, we want to start aggregating data back so that we can actually update things as we see fit. Now, one of the things I noticed here is we're getting a watch session ID back of none. So perhaps that's related to the object itself. It looks like the object might not actually be setting it. So we might want to check that as well. But overall, right now, we should be ready to start aggregating data for any given session or any given video. As the last step of associating session data, I want to ensure that the session ID actually exists. It's like a real one. So that's what we're going to do now. Either way, even if it's not a real one, we still are going to track the YouTube watch event, because if the session for whatever reason is failing, we can see the watch event and get a lot more data in there. And of course, if we were collecting more headers like an IP or something like that, we would then be able to help coordinate where this is all coming from. So this part can get a lot more complex, but the idea here is seeing the early stages of verifying a session ID. So what we're going to do then is on our front end, we want to actually send the session ID to being something different. So I'm going to come in here and I'm just going to change the session ID to ABC. I did have a little typo in this console log, but if I change the session ID to ABC, what I should see on my back end is that is the session that's coming through. Of course, we don't want that. So what we want instead is inside of this create event, we just want to verify that that session ID even exists. So down here in the object where we're actually setting the YouTube watch event, we're going to go ahead and say if session ID. And here we want to verify it against the database itself. So what I'm going to go ahead and do then is I'm actually going to change it from session ID to watch session ID, just to make it a little bit easier on me to distinguish between the database session and this watch session ID. Okay, so with this in mind, I now have the same stuff going on, but I need to bring in my other model. So my watch session model, we'll bring it into our routing with our import here. So from api.watchSessions.models, import that watch session. Okay, and so what I want to do is I want to execute inside of the database something related to this. So it's going to be basically our watch session object is going to be equal to our database session.execute, and we want to execute some sort of query. So what I'm going to do then is going to be our watch session query. I'll just call it that just to make it a little bit separate from the execution of that query. And so what we need to do is we need to run select. Select, of course, is a SQLModel command that helps us, really build out our actual SQL query. And we're going to be selecting the watch session model or the watch session table. .where, this .where is just basically saying, hey, what condition do we want to select here? And of course, that's going to be our watch session ID. We want to see what is equal to that watch session ID. Now, the what is equal is going to be based off of the model. So going into the model, it's the watch session ID. What do you know? So back into our routing here, we're going to go ahead and do our model dot the actual field name, which again is watch session ID. There is our query there. So now I can pass in this query to be executed. And this then would be .first to see if there's one single object, because there should be one single object where that makes sense. If that exists, then we're going to go ahead and set that session ID. This will change what's coming through because now it's giving a session ID of none. It's no longer that ABC one. So if I were to switch it back to being the actual session ID, then we should be able to see that one as well. So going back into our backend here, now it's actually showing the correct session ID, in which case they would have to have set that up within the database itself. But of course, when it comes to a session, we might want to track when the last time that session was being used as well. So it's another thing that we can consider doing, which is jumping into, let's say, our model here. We could add in a new field. What I'm going to do is I'm going to add in a field called last active. This is going to be an optional date time field. And then we're going to go ahead and set it as a field here. And we'll go ahead and do our default factory, very similar to what we've seen before. This time what I'm going to do though is I'm going to go ahead and bring in from TimescaleModel. So let's go ahead and go into the definition there. I'm just going to grab this get UTC now method and then basically grab that as my default factory that I'm going to use. Okay, so last active is now in here. What I need to do, of course, is I need to bring down my database. So we'll go ahead and do that with docker compose down -v, bring it all down and all that. While that's working, what we'll do is come into routing here and basically grab this particular object, very similar to what we're doing with the YouTube watch event object. And then if it exists, we're going to go ahead and grab that one with obj, the actual watch session object, and then we'll do .last active equaling to, well, once again, I'm going to use that same exact get UTC now method, and then we'll go ahead and set that right here. And then I'll go ahead and do my db session.add, and we're going to add that just like that. And all the commit and refresh stuff will happen down here. This is just allowing us to update that model itself if we need to. Okay, so with that in mind, we're going to go ahead and now bring back up our Docker Compose. So let's go ahead and do that. And at this point, I might have to save it twice just to make sure the application's running. We got our watch session ID in here that's not actually working anymore because we deleted the old one, right? And so this is where we might have to let the front end know that that session is no longer valid, right? So that's another thing in here where perhaps instead of going through this process, we might also have something more along the lines of if not watch session object, and then returning some sort of 400 error where they might have to reinstall or relog into their session, which of course is not something I'm going to do right now. Instead, I'm just going to go ahead and open up a new tab here, and then this new tab should actually handle that for us as far as the session is concerned, because it would have just created a brand new one, in which case this is what we see right there. It is creating that brand new one coming through with our session ID. Fantastic. So now that we have these valid sessions, it's going to be a lot easier to actually aggregate them correctly and ignore ones that just simply don't have a valid session whatsoever. And of course, if we had our user, we would be able to do a lot of these same sort of things with that user themselves to just add them to either the session, the actual watch event, or both. We're now going to start the process of aggregating our video stats for our front end so we can see them and how they happen over time. So the first thing that I want to do is I want to import from date time. We're going to import the date time and time delta and then time zone. And then from our TimescaleDB, we'll go ahead and do from TimescaleDB .hyperfunctions. We're going to import the time bucket function. Okay, so the idea here is we want to create a brand new route. This is going to be router.get, and we want it with the video ID. This, of course, will give us the video ID that will pass into the function itself. So I'll call this video stats or get video stats. That, of course, will take in the video ID with the str there. And then we also want to have the database itself, because that's what we're doing right now. We're going to be doing a database query altogether. Okay. And so we'll paste this in here as well. And then we will now start the process of actually returning some data. So what is it that I'm trying to do here? Well, first off, I need to go ahead and select the video events related to the video ID. Then I want to aggregate them to have like averages or counts. So that's really the idea here. But of course, between time. So between time is a big part, and of course, that's why we use something like TimescaleDB, is because of how we can chunk it. So let's start with the time first, the actual buckets of time we want to use. So what we do here is we declare a bucket, and we use the time bucket function, and then we can set something like 1 day, or 1 minute, or 1 month, really depending on what scale we want to analyze this data at. I'm going to go ahead and do 1 minute because the data I've been working with has only really happened in the last like 24 hours, if even that, because I've deleted the database a few times. But the idea here is we've got 1 minute is the time bucket we want to use. And then we want to do it on a specific actual field. So what is the field going to be? Well, it starts with what's the table, of course. It's going to be our YouTube watch event table. That actually makes the most sense because that's what we store the data in. So that's the table I'm going to be using. And then of course, if we go back to that table and we see that it is a timescale model, we can go to the definition and we want to grab this time field. This is going to be the default every time. So basically, whenever you're using that bucket itself, so let's go back into it. Whenever you're using time bucket here, you're pretty much always going to be doing dot time, that time column for the specific table. So that's an important part of this. But now that we have this minute, we now need to specify a range. So like a start range as in date time dot, we want to grab now and time zone and then .utc, and then we're going to go ahead and subtract a time delta. And then of course, this is going to be maybe something like hours being 24 hours or 25 hours. Let's do 25 hours so we give ourselves like an hour delta or an hour buffer, if you will. Okay, so the idea here is 25 hours ago is going to be our start. So then our end will be date time and basically the same thing, but we'll subtract 1 hour. So it's a 25 or 24 hour period here that will give us 1 minute increments. So when it comes to like a whole day, 1 minute increments might be too granular of data. So maybe you want to do something more like 30-minute increments, right? Or maybe you want to do 1 hour. Either way, you can just decide that with your time bucket on how you see it. But the point is the actual duration, the actual buckets themselves should probably fall inside of something that makes sense for the start and end times. So if we were going to do a whole year, you'd probably not do 30-minute increments, although you definitely could. It would just be a much bigger query. It would probably take a little bit longer than something like this, where the 30-minute increments over 24 hours is not really that much data. But the point is you can play around with it, and you definitely should. So now that we've got the kind of time that we want to use, we just move to the next part and we start defining the query that we're going to actually submit for this. So the first thing about this query is we need to use select. We just make sure that we imported select from SQLModel. Sure enough, we did. Or from SQL Alchemy, we're going to import the func function. So we'll go ahead and use that one as well. But the idea is, of course, we're selecting the exact same table, right? So absolutely want to select that table. And then what is it that we want to select? Like as in what fields are we trying to get from this table? Well, in our case, we're just going to go ahead and grab the video ID. Now we also want to select it based off of this bucket, which of course uses a field in that table as well. So in many ways it is using the actual field of time. So we're grabbing that time bucket itself. And so at the bare minimum, this actually works pretty well in terms of our select. We'll stick with this for just a moment. And then I'll go ahead and do .where. Now this where clause is where we're going to have our start and end times in here for, right? So basically we grab this same sort of thing here. We're going to go ahead and say where the time is greater than start, and then where the time is less than or equal to the end. And then the final one would be something along the video ID, right? So it actually makes sense that we would do the item itself with the video ID equaling to this video ID. So in other words, we are selecting only events that are related to the video ID that's coming through. There might not be any, but in this case we would. So if we had a user, we would probably put the user in here as well if we wanted to, specify it based off of the user. But in this case, this is fine. Next up, what we want to do is a group by method here. This group by is going to be grouping based off of the bucket itself. And then of course we could also put in the video ID, but in this case we are only using that video ID, so we really don't need to group it this way. In other words, if I removed this, then the grouping makes sense. If I have it, the grouping doesn't make sense. I want to keep it with the video ID, so we don't really need that. It's just kind of extra, if you will. And then the next one would be something like order by, and then the bucket itself is probably just fine in terms of the ordering. But again, we can also use the video ID too if we wanted to order the video ID in there as well. But the idea, this is a very simple query altogether. And now with this query, we just grab our results. So we'd say something like results equals to db.session.execute of that query. And then we're going to go ahead and do fetch all. And then we're going to go ahead and return back those results, whatever they might end up being. Now, of course, getting this data is going to be a little tricky in terms of our testing. So all I want to do here is bring out those results, and then we want to make sure everything's running. It looks like everything is running. And of course, I still have a bunch of sessions data coming through based off of these videos. But what I want to do now is I'm going to go ahead and open up the API video events / that ID there, just to make sure that I can actually pull it out or actually see some data in there. what I'm getting right now is an error in here related to some of this data. So we're going to probably have to diagnose what that error is. Let's actually, I think it's related to the results themselves and actually, putting it into a different format so that we can return what that data might be. As in when we used our original response, we have a response model in here that has a different data format. So we are going to have to serialize this data very, very soon. Now, before I do that, what I might want to do here is basically just grab this data, and I'll go ahead and say something along the lines of results equals to, we'll just go ahead and grab the data in terms of the positions there are. So this is going to be the 0th element, and this is going to be the first element. So all I'm going to do here is string of x of 0, comma, we're going to do comma, the string of x of 1, and then we'll do for x in results, and then I'll put this into a tuple itself, like that, and then put a comma at the very end of it. So it is a tuple. Okay, let's make sure that that's working. We've got string of x of 0 and string of x of 1 in those results. Maybe let's get rid of that comma there and put the tuple right there. Okay, let's see if that ends up giving us some data back. Let's go back onto the API endpoint, and there's some data back. Okay, great. So it is showing us some data. It's not giving us much, but it is at least showing us data. We want to serialize this stuff very soon, but let's go to the next part where it actually gives us some data. So the way we're going to do that then is actually counting things. So now with this next step, it would be comma, and then we would actually do something like function.count, and then we can add a label here, and we'll go ahead and say total events, something like that, based off of this data. Because up until this point, we didn't have anything that we were really aggregating. It was just like, hey, how many events are there? Or like we're only selecting the video and the time bucket in the last 30 minutes. That just meant that there are some events, we just don't know how many, and now we'll know how many. And this one's going to be the second element here. So once again, I'll do string of x of 2, and then we should be able to see this data come through. Let's take a look, and there we go. We've got 234 events in the last 30 minutes. Let's change it into being based off of a single minute. So we do 1 minute increments now. We refresh. Now we get a lot of other data. So at this timestamp, we've got 42 events. At this timestamp, we got 40 and so on, right? So that's going to keep going through. And now we've got aggregations of this data based off of time buckets. So all we really need to do from here is start expanding what these do so that our front end can actually see them if we want to start analyzing the data, which of course we do. We now want a response model for our video stats. This is going to be fairly straightforward based off of Pydantic. But of course, the point here is we want to make sure that we're getting these 3 items in here with the correct data types and using Pydantic to do so. So the way this is going to work is we're going to jump into models.py here. We're going to go ahead and create a class. I'm going to call this my video stat, and it's going to take in the base model itself, which of course means that we need to import that one. So I'll go ahead and come in here and do from Pydantic. We're going to import the base model. And then I'm also going to do the Pydantic field, or rather field as Pydantic field, so that we can use that one as well. So coming back down in here, we're going to have our base model here. The very first one is going to be something along the lines of time. This is going to be a datetime object itself. And that's pretty much always going to come through. So yeah, we can definitely have that one in there because we're using time buckets. Next up is going to be the video ID, also going to be always coming through in there. And then finally, we would have something like our total events, and then this is going to be an integer, most likely. Okay, so another thing that we might consider doing is something along the lines of a max viewership, like the maximum amount somebody's watched, for example. This is probably going to be an optional float value, and this we want the Pydantic field and the default being 0. Okay, so we'll take a look at this in just a moment, but the idea, of course, is using this Pydantic model in our response events. So inside of our get video stat here, or rather the actual router itself, we want a response model, and we'll go ahead and do the response model equals to the list of that value. So we need to make sure that we're bringing both of those things in. So inside of the models import here, I'm going to go ahead and put right underneath this the video stat. And then we'll also go ahead and import, from typing, we will go ahead and import list as well. Great. So now that we've got this video stat in here that is looking for that response model, what we can do is inside of our results now, we can actually just initialize that data and then go through each step. So time being, this was X of 0, and then the next one, it's basically the order that we've got here is what we're going to be doing. The next one was the video ID, and that is X of 1. And then the final one is going to be the total events, which we said was total events equals to X of 2. Okay, so now we've got that. There is our new results here, and we just have a little bit better of a serializer if you ask me. So that's going to loop through everything. And so if I refresh in here, it's now JSON serialized data instead of the weird string stuff that we had before. And now it's giving us a bunch of things in here. Now what we notice is our max viewership is all zeros. So one of the things we might consider for our default here is doing something like -1, like that, right? So if we do -1, then on the front end, we'll know that that's just not a set value. Of course, we could always put it as null, but using something like -1 also helps us understand that, well, if there is a 0 value, then we want to make sure that that's in there. So the question then is, what are we going to calculate for our max value, like the actual max viewership stuff? So we actually want to use that. So we'll go ahead and come in here first and say, max viewership equals to 0, right? It's certainly possible that it will be 0. It depends on how things actually shake out. But the default, we can leave it as -1 if the 0 is not actually there. So the way we're going to do this then to get our max viewership is we're going to use function again. I'll put a comma here. And we're going to go ahead and do function.max. And what are we trying to max out here? We're trying to get the top level of what's the most somebody has watched. So if we looked at this and we came back up, we would see current time is most likely going to be that, because the maximum that was ever done on all of the watch events, that's what we're trying to get. This is one of the reasons that having the correct data type is so important, is so that you can use functions like this and you can then go YouTube watch event dot and then current time, and then function.max is just going to find it, and we can give it a label still, and we can just go ahead and say max viewership, just like we did on the back end. If we want to label it, you don't necessarily have to because of how we're actually using that data. So then down here, you would just come in and do X of 3 based off of its position, and then we actually take a look, we refresh in here, we can see that there's still a lot of zeros coming through. But there's also, which is correct, right? It's not negative anymore. It's zeroed out because, well, nobody watched anything, although events did happen, which is pretty interesting. So now we see that there are some that do have events in here, and they do have a lot of time watched, or at the very least, a lot of milliseconds watched, if you will. So it's not necessarily a lot of time, but it is at least allowing for us to see that we can actually maximize those things out. Now you could do the same thing with averages as well. So we could take the same exact idea, put a comma here, and do average, so you can get the average current time, like what people watch on average. And that's another thing that we could add in here, in which case we would want to bring in average viewership. We could use that same label here. We would come down and just do X of 4. And then of course, the reason that's white is because the model itself doesn't actually have that argument. So let's go back into that model, scroll on down, and same sort of idea here is we would bring this in like that. So now we have that video stat, and we can refresh in here. Now we're getting all sorts of stats coming through. So the average viewership, -1. That means that there is no average basically, but then somewhere in here we should probably see averages. It doesn't look like it's being set. So perhaps I needed to set it in both places. Maybe it just wasn't set in both places. So let's make sure we're saving everything. And then we'll refresh in here. There are some averages, and now again, it's going to 0 because it's just no data. It's not going to average to negative if there is none. Okay, cool. So we see the max viewership is coming on this edge, whereas the average viewership is right here. So there are, of course, more things that we could do to that actual data. We can round things, we can do all that. I'm not going to do that at this point. It's really just about how we can aggregate all of this data. The other part that's really cool about this is we could put in 1 day, we refresh in here, there's 1 day, total number of events, the average viewership, that's all well and good. Now there is one more thing that you might consider doing, which would be maybe the actual count related to the actual unique views, something like that. So let's go ahead and add that now. I'm going to put this at the very end, just based off of position, so I don't really have to do it again. But the idea here is we're going to go ahead and do a count again. This time inside of the count, we're going to do another one called funct and distinct. And the function for distinction or distinct function, we then are going to count by the watch session ID. So basically we want to get the distinct views based off of the watch session. This is a little bit different than what we saw before. This is going to be label, and you would call this something like unique views. So total events, unique views, definitely different, of course. Then we can come in here and say unique views is x of 5. And let's go ahead and do that. And then we'll come back into our model here. And once again, I'll go ahead and have an optional value. This time it should be actual integers, but I'll go ahead and do optional int, and the Pydantic field here, default being -1. Okay, so we're going to save in both places. Let's make sure it's all saved up. And now if I refresh in here, now I get 2 unique views across this based off of my different sessions. So what I want to do then is I want to create a new session, and maybe even create one in an incognito window, play it a little bit and see how this shakes out. So I'm going to just run this a little bit, play it. Okay, great. And then I'll refresh in my API and I should get additional unique views. But right now it's not showing additional unique views. Why is that? It should, shouldn't it? Well, no, actually, because I literally changed the end to an hour ago, not 5 minutes ago, an hour ago. So let's go ahead and change it to, let's say minutes being 1. Okay, so now it's probably going to include it. So let's refresh in here. Maybe it hasn't been quite a minute yet, but the idea is eventually it should actually include it in there. Let's go ahead and do seconds. Let's see if that actually solves that problem for us. There's those unique views. Great. So let's try that once again, just to verify that it is working. So yet another session in here. I'm going to go ahead and play it. I'm going to fast forward a little bit and see what's going on there. That should have done it. Going back into my API, there's my unique views. So now we have a way to have unique views. We have all of these aggregations. This is actually a really, I think, powerful way to go about doing this, and not that much lift. It's not that challenging, I don't think, other than maybe learning a bunch of new syntax potentially. But as far as actually running these queries and how effective they can be, well, they're there. They're ready to go. And now you have a way to get unique views on your different queries, and also, of course, aggregating all this data so you can see it across the board. I now want to be able to modify the bucket start and end time on demand. So we'll start with the bucket and go from there. The first thing that we need to do is bring in the request object itself to the view in here, just like we did before. And of course, the actual location it is doesn't really matter so much. But what we want here now is going to be something like params equals to request dot query params. So in here, I'm going to go ahead and grab the, I'll call it the bucket param, and this is going to be params.get, and we'll call this bucket. And then I'll go ahead and have a default of 1 day. Okay, so I'm going to go ahead and use this now as my bucket parameter here. So doing this allows for a lot of cool stuff. So going back into my endpoint, I'll just come in here and do something like bucket equals to 1 minute. Now I can just rapidly switch what's going on, which of course is going to be ideal for our front end to actually consume this. But of course I do need to solve a problem, which would be if I used an invalid query parameter. So if I said 1mn, I get this invalid server error. So there's a lot of different ways on how we can think about solving this. One of the ways would be to create a function that ensures that this actual query param follows the format of like a number or an integer followed by like some sort of duration, whether it's day, minute, hour, so on. But that of course adds in a bunch of complexity that we just don't want to handle at this point. So one of the easiest ways to solve this then would be something like using an HTTP exception. And then instead of returning back that internal server error, we'll just go to these results here and do something like try And then if there's any sort of errors with that, basically I would then go ahead and raise the HTTP exception with a status code of 400, and then maybe some detail saying like invalid query params or something like that, or maybe just invalid query. And then we can save that in there, in which case it now does that. So we would just need to update this to something like minute or days, right? Or months and so on. Cool. So now that we've got that actual ability, we can actually take it one step further and also have the start and end time. So if you're going to be changing the time bucket parameter, you should also change the actual query parameter too, to be associated with that, so we don't get all of the data. Now, in this case, it might be a question of like, oh, maybe my start time is the only thing I really care about up until today, but every once in a while, you might want to chunk it to different times, in which case we want to have a start and end time, which of course is why we did that in the first place. So how do we go about doing this? Well, the way I want to do it is grabbing basically hours ago. So I'm going to go ahead and say something like hours ago being our param. So we're going to go ahead and do param.get. This is going to be hours dash ago, or the fallback, whatever we want to call it, at 25. And then hours until and params.get hours and until, and then I'll go ahead and say or 0. Okay, so now it's not going to be as granular as before. We could, of course, change this to seconds if we wanted to, but I think overall hours is probably going to be plenty, unless, of course, you need to get really nitty-gritty. But when it comes to videos, I think using hours is probably okay up until now, essentially. But, of course, you can always change the time bucket on how it's chunked. It's just more of like the span of the data is what we're looking at right now, not how it's chunked. The time bucket will be the chunk. The span will be these that we're working on. Okay, so once again, with the actual query params here, we could have some issues with this. So what I want to do here is, like, if our query parameter has a number, it's probably no big deal. So if I do hours ago and do like, I don't know, 10, and then something like hours until, and then I do 0 or 1, let's go ahead and do something like that. We get that same sort of data. And of course, now it's in days, so let's change the bucket to minutes so we can just see those things going on. So that's probably about 10 hours ago. I'm not really going to check that. But the idea here, of course, is we can update these spans. But if I were to do an issue, like put hours until and do a B or something, and then maybe in here, oh, it looks like maybe I'm not saving things. So let's go ahead and make sure we are doing that. Let's try that again. And now we get a server error. Okay, so we don't want that server error. So what I'm going to do then instead is I'm going to create a simple utility function, and it's going to be simply parse int or fallback. And basically it's going to be our int string and then our fallback being whatever number we want it to be. And I'll go ahead and say our value is equal to our fallback initially. Otherwise, we'll just go ahead and do try and say value equals to the int of the int string. And then we can accept that and just say pass, and then we'll just return back the value. Simple enough. So now in our get or, we'll just go ahead and say that value parse int or fallback, and then we'll just go ahead and set the fallback itself. And oops, I need to put that around the parameter get itself. There we go. And then we do fallback equals to whatever that value is going to be. And that's just a simple way to make it all in line instead of having a bunch of code going on here. And of course, I'm going to do that same thing down here and just change this to hours until and fallback being 0. Because in this case, it's like, oh, we should just definitely go back to the fallback itself. And then there we go. So now I can refresh this. And if there's an issue with the hours ago, that's a whole different story than the bucket itself. So sticking with that fallback, I think, is pretty cool. Okay, so now that we've got this, one of the things I would probably want to do with this is maybe I can improve it a little bit overall. One of the things I would probably end up doing is inside of my API, I might do utils.py here, paste that in there, and then I would just come in and do our from api.utils import, the parse int or fallback method in there. I'm not sure why Python doesn't have something like that native, but it doesn't. So here we are with our fallbacks in there, and there we go. So now we have a little bit better of the parameters we can bring in here so that when we do integrate this with the front end, we can see just better data overall. So hours ago, I could do like, 48 hours ago, and we would have all of that coming through. So this also comes back to then, what should our response model be? Should it still be this list here, or should we also show the bucket and the time stuff in there. That's something you could definitely think about. I'm actually not going to do it. I'm going to leave it as is. But the idea here is having our response model maybe being a little bit more verbose in terms of the response data that's coming through and not just being a list of data. But we're going to leave it as is. Now let's go ahead and bring this into the front end. Let's add a metrics table to our actual video. Of course, this is going to be implementing the raw data from our backend for any given time bucket. Initially, we'll just use the defaults, then we'll make a form that allows us to change things. And when we want to change things, SWR is one of the best ways to do that. It's a really simple way to just revalidate or just re-grab new data. And it makes things really simple for us. All we really need to do is have a few parameters for it and it ends up working. So what we want to do then is jump into our watch component here. And I'm just going to go ahead and call this metrics table.jsx. And we're going to go ahead and export the default function called metrics table. And of course, what it's going to take in is the video ID. And then we'll return back some data here. In this case, I'll just return back metrics for the video ID. We'll just start there. The video ID is absolutely required. And I'm going to go ahead and do use client here. SWR needs client in this case. Okay, so now that we've got this metrics table, let's jump back into our watch page to the very bottom here. And I'll go ahead and do metrics table. Now at this time, I probably can remove some of these old things that we had on there, which of course was this right here and all that. And of course the video title actually went away because we made some changes there. So I can go ahead and do video title. I'll go ahead and get rid of this right here and maybe even add in a H1 class name. And we'll go ahead and do text XL or something like that. That way it's a little bit bigger. We can do the spacing, all that later. I'll also get rid of the player state. We no longer need that. Now, notice my metrics table is still saying metrics for video ID. I didn't actually pass in the video ID. So I want to start this off with basically saying, if not video ID, then we're going to go ahead and return back just nothing, right? So we don't actually want any sort of value in there. So we can just leave it as is. And I'll just do that right there. Okay, great. So with that in mind, we now have this a little bit better formatted. So let's go ahead and implement the SWR method. So the way we're going to do this is npm I SWR, just installing SWR itself. And of course, if you go into the SWR documentation from Vercel, you can scroll on down and you can see exactly what it is that we're going to be doing here. So first and foremost, we're going to go ahead and import use SWR, and then we'll go ahead and import some of these things right here. Just like that. Now in the case of the video ID, I'm actually going to be using that in my URL. So I actually want to put this up. So if the video ID is not being passed as a parameter, then I don't want to render anything or even try to do use SWR. So that also means that then in my page here, I'll go ahead and add in my video ID, which is of course using that underscore like we saw before. I'm going to be using camelCase because that's the JavaScript convention. So this is a very much a JavaScript element here that we're putting together. Okay, so what is it going to be as far as the endpoint is concerned? Well, we already have this endpoint in a couple places, but the idea is, of course, this FastAPI endpoint, we can use that same one in here as our base URL. So I'll go ahead and say URL equals to almost the FastAPI endpoint only, but of course, you're probably going to remember what we need to add to it, and that, of course, is the video ID, whatever's coming through for that. And that's going to be the actual URL that we'll end up using. We might need a trailing slash as well. Let's just go to the back end just to make sure. Looks like I don't actually have a trailing slash on here, so I'm going to leave it out. And so there we go. We've got our URL in here that we would use to do the fetching, or almost. So one of the things we have to remember when it comes to using this data is perhaps we also want to include our session ID. Now, in this case, it's actually optional. Our actual backend doesn't really use the session ID at all. But if for some reason you wanted to use it, or maybe you wanted to store data related to the session, as in like who's looking up this data, you could also store that as well. So like if someone's doing a request, you could do something similar to what we did up here where we use that session ID to add it to the database as well. In our case, we're not going to do any of that. We're just going to go ahead and allow for it to be used in case you ever do want to use it. So that means back into our metrics table, I'm going to go ahead and do use session, or let's say use watch session, I think it was. So use watch session, we'll bring that in. And of course we need to pass in the video ID here as well. And then in this case, we'll go ahead and do const session ID, which we used as an underscore, I believe, over here. There it is. We now have that session ID in here as well. So why is it that I'm grabbing this now? It has everything to do with the fetcher function that useSWR has. So if you look in the getting started portion here, we can see that there's this fetcher quick start part where we need to use that fetcher. So in our case, we're going to go ahead and put that fetcher right above the useSWR. Now, most of the time, what I would end up doing with fetcher is I would store it somewhere else, like in a lib or something like that. But I actually need to modify the fetcher to make sure that it's working correctly. So right now it has these arguments in here just like this. Now, this fetch call is the same exact fetch call that we've seen before inside of our update backend. It's this same one right here. So we've got a URL and then optional arguments that might be coming through. In our case, we're just going to go ahead and pass in the URL, whatever the URL ends up being. We're also going to put that URL right inside of the fetcher itself. We don't need all of those different parameters per se. Then what I'm going to do is pass in my headers here, and this is going to be equal to, well, let's go ahead and create a headers object in here. And this, of course, is going to be just like what we saw before, which is this one right here. So I'll go ahead and add in headers and headers. Okay, so this will allow me to use that session ID. That part is completely optional. You don't necessarily need it, but when you do need it, you want to make sure you have it. So this is allowing for that to happen, and that useWatchSession hook should work just fine in terms of that. Great, so now that we've got that, hopefully what we'll end up seeing is the actual data loading. So I'll go ahead and do console log data here. Let's make sure that everything's running. We'll jump into our project. I'm going to go ahead and inspect the element. I don't have any errors just yet. But now I've got some data coming through in here that's coming from the backend. Fantastic. So that actually means that our table's starting to work. So what I want to do is I'm going to come down here and we're going to do a minimum of our table. And all I'm going to do here is I'm going to run through a table element, and I'm going to go ahead and do a tbody, table body there. And then we're going to go ahead and do our data.map. And this is going to take in our value and the index value, so IDX, and we're going to go ahead and return back a table row. And then I'll just go ahead and say return. We'll just do return table row, and then we'll add a key in here of IDX. And so what are the values that we want to return back? Well, TD, we can do the value, and let's actually just stringify it first. So we'll just do JSON.stringify of that value, just so we can see what's in there. I mean, you probably should already know what's in there, but let's go ahead and see what's in there, and let's just see if it's rendering. Looks like it's rendering. So we've got time, we've got video ID, which we probably don't need to render, total events, max viewership, average, and view counts. Cool. So that's what we could do. We could then just come in here and do something like, value.time, and then we could just repeat this process a couple more times for each key value pair. So total events, we've got max viewership, we've got average viewership, and unique views. Again, we don't need the video ID based off of what's being requested. So now if we come in here, save that and refresh, we now are getting closer to what we might want this to look like. Now, in my case, I'm actually going to go ahead and just give you the CSS and all that, the tailwind stuff of it all. But the point is, I just wanted to show you how you might think about doing the table itself. And so I'm going to go ahead and paste in over this table some CSS and tailwind stuff that's in there. Notice that I've got the date, total events, max viewership, all the same stuff, just with a bunch of classes in here. And so if I save it now, I can see that data coming through. And of course, this is going based off of the default values that are coming through from the backend. So as in, we put nothing in there. There are the two default values that are coming back with our project here, right? And so that's an important part of this. We see now these max events. This is great. So this is where we could stop if we wanted to, but of course we want to be able to modify this table so that we can change at least the time bucket, and then maybe talk about the other things that we might want to have in there, or the chunks, if you will. We now want to allow our users to select the time bucket so we can chunk the data differently how the user might want to see it. So the idea here, of course, is we're going to go into our front end and we'll just go ahead and start off with a simple one where we just do const time bucket and we set it equal to, let's say, 1 minute. As soon as we have something like this, we can add it to our URL and useSWR will automatically change it. And so I'm going to go ahead and put a question mark bucket equals to that value. And let's make sure we put a $sign there. And now we'll be able to change it accordingly. As soon as I add that, I should be able to see on my front end all of these different events. Granted, I have different events over time, so that's why it's able to show all of the different ones that are in there based off of that time bucket. If you didn't, then of course it wouldn't necessarily work. But the idea here is now we've got all of these metrics, so I want to turn those into a drop-down, so basically I can change what this value ends up being. And so let's go ahead and take a look at how we do that now. Now, first and foremost, in our components, this is where we're gonna create something called timeBucketSelector.jsx. Now, I've actually already created the selector itself. It's really straightforward. So I'm gonna go ahead and paste it in here and show you exactly what it is that it is. So first off, we've got our bucket unit options. Notice all of the different options that we have. These are going to be our selector. These are going to be the drop-down elements themselves. And then we've got an input for numbers themselves. Very straightforward, just with some classes in here and all of that. We've got a minimum bucket at 1 that I think is going to be a requirement. So with that in mind, let's go ahead and bring it now into our metrics table. And I'm just going to put it right above the table. And we'll go ahead and do our bucket selector here. So I'm going to go ahead and do time bucket selector, and then I'm going to go ahead and close it out. Now, first off, if we just take a look, we probably will see it rendered in here. So there it is rendered. We want to have some default values in here. Right now, there are none. So the default values are going to be based off of these right here. So in other words, I'm going to go ahead and copy those and just paste it in here so we can set those values. So first off, we're going to go ahead and do bucket and then set bucket. And there's going to be use state and what value do we want on the bucket itself. We're going to stick with 1 and then const bucket unit and set bucket unit. And we'll go ahead and do use state. And in this case, we'll do, let's say weeks. Okay, so every 1 week, that's going to be those different units in here. And so now we could just come in here and set those like this. Just set them equal to themselves, basically. Unit might be the wrong thing. Maybe we call it interval to fit better with timescale itself. But in the front end, I think calling it unit just works just fine. So we'll leave it as is. And there we go. So now I should be able to change the time bucket itself. And the way I'm going to change that is by just coming in here and doing the bucket and bucket unit. And that will be the actual time bucket string that we will bring in. Save that. And now if we go back in here, we've got 1 weeks. If I change it to 1 minutes or something along those lines, there we go. So that's it. That now allows me to modify these things on the fly and I don't really have to do anything else, which is pretty fantastic. Now you also might do quarters in here, like 3 months or something like that. But as far as the dropdown is concerned, this is actually pretty straightforward, I think. So the next thing would be like the range. And the reason I'm not going to do that is it just adds in some complexity to the front end that we just don't necessarily need to do. But we have a few options that I'll mention right now. First off, we can use something very similar to the time bucket, but we might need to change our back end. Instead of being hours ago, maybe we do a start date and an end date instead of hours ago or hours until. Now we could also keep hours ago and hours until as is, and then modify what the front end does for the start date and end date. In other words, doing some math in the front end to get that hours ago and hours until. In my case, I'm going to just go ahead and cover the last, 30 days or maybe 3 months actually. So let's go ahead and do 24 hours times 31 days times 3 months. And that will cover the last 3 months. So really this is going to be chunking it based off of months. So realistically, I probably don't need years in here because I just simply don't have that data. But of course, you totally could adjust it as you see fit. But the nice thing is we now see that that's essentially the start time of this year itself, which may or may not be what you want to do. So nevertheless, we now have a way to grab all of the different data points in here for our front end, and we could do all sorts of stuff with it in terms of analyzing our data. And one of the things you'll probably notice is it's actually pretty fast on doing all of these requests. use SWR helps make it fast, but of course, using FastAPI and Timescale also helps make it fast as well. So it's pretty cool. Now, of course, the next thing would be something along the lines of, if we start playing more data, does this actually change in real time down here? That part won't necessarily happen, right? It's not necessarily going to grab real-time data showing up down there. And of course, we would need to change stuff a little bit to make sure that that even does change. And of course, if we go back into seconds here, we might need to change this to timestamps if we're doing seconds. But here's all of the different events that are actually coming through that are just not quite showing up. And I think the newest one is actually on the bottom, which is a ton of data. So not sure if you want to have that range in there or not. You probably do want to have the range just because of that ton of data there. But this is kind of where we're going to leave it in terms of seeing the actual data at this point. We need to improve our metrics table before we go any further. The first one is related to the display, this date right here. If I were to change it to hours, it's still a date. It doesn't show any of the hours. I want to see the entire time bucket itself. So there's a couple of different ways on how we could do this. We could just literally do val.time, save that, and that would actually give us that same information. This, of course, is not super well formatted, though, in terms of a user. So instead of doing that, I'm going to leave it in as toString, and that gives me a little bit better of a format for the user, and I think off of your own time zone as well, because that is, roughly speaking, the correct time zone. So the idea here is we've got now hours in here, and of course, if I were to go to minutes, I can see that. The other thing about the actual time now, it's also showing me that it's going up in time instead of being the reverse, which I would actually want to see the most recent one first. So in order for me to be able to do that, of course, I need to go back to my backend here, and I need to change how this data is ordered. So it's not what I'm selecting, it's not what I'm narrowing down, it's not what I'm grouping things by, it's literally the order. The nice thing is we can actually test out a few different ways on how we can do this. Whenever it comes to ordering inside of SQLModel, you can do ascending order. If we save that and refresh in here, what we will get is the default actually. So that's the default value, is it's going to go in ascending order. We want it in descending order, or the reverse order, so we can actually see the most recent first. Great, so that's fantastic. The other thing that we want to test here is when we go to actually watch an entire video. Let's say, for instance, I watch this whole thing. This is a lot of seconds that I've now watched, right? So if I play that, the max viewership most recently should be really high. So I'm gonna go ahead and refresh in here, and we'll go into minutes, and it's not that high. This is saying basically 17 seconds. So that's the incorrect value. So right now we gotta wonder, are we storing it correctly, or are we displaying it incorrectly? So both things we can test out or take a look at. First off, if we look at our metrics table, the very first thing here is it is being divided by 1,000. So I have an intuition that that's incorrect. This is basically saying it's taking in the milliseconds, or ms, right? Which would assume that these are seconds and we're dividing it by milliseconds, in which case that would be actual seconds, would be correct if that's what it was storing. But of course, if we actually take a look at our use YouTube player data in here, what we would see is, of course, nothing really solidified as to what the data is, but this is saying current time. So what we could do, of course, is we could just console log what that current time is. I probably should have thought about this before, but let's go ahead and inspect the element here, and I want to go ahead and say current time, and we can just sort of infer what's going on as soon as we go to play it. We should get what the current time is, assuming that I saved everything. I'm not sure if I saved everything. Let's refresh again and run it there. There we go. So now we're getting that current time was coming through, and what we should see is 2:02 and so on. So at the very beginning, it's showing me 2:02. So if I go to 0, let me zero it out here at the very beginning, and what we should see is something like 0, 1, 3, 4. In other words, this is current time seconds. That's really all we need to know about that. So we're going to go ahead and change that to being seconds, and change that one to being seconds as well, which means then that the actual data, the current time data, is also in seconds. So this is going to be max viewership in seconds, and in seconds, right? The average in seconds, which means that my display was wrong. That's it. Not that big of a deal. We just changed this to 60 to change it into minutes. Change this to 60, also change it into minutes. That display is probably fine now that we've got that. Great. That's a lot more accurate to what I've been playing around with on this video. And we can always test this out too by just going in, like for our most recent event, going nuts on it. And we can even go into seconds here in terms of granularity. And there we got 283.31 minutes. So if I do a quick Google search for this, 208 minutes to hours or something like that. Oh man, seconds is really slowing everything down. I'm going to go ahead and go back into minutes. But we've got 4.7 hours, which I think is about correct for this video. I noticed that as soon as I went into seconds, it was just way too granular, slowing things down a ton. So what I'm going to do here is in my time bucket select, I'm going to get rid of seconds. I don't want it at all because of how much it was slowing down my browser. Minutes is probably, could also do that as well. This is where caching and taking snapshots, things we'll talk about later, will definitely come into play and be an important factor in terms of analyzing this data. But the point here was to actually take a look at it in this way. But there's still one more thing that we want to think about, and that is in terms of these total events, right? So 7 unique views, 6,000 total events. Why is that? What's going on here in terms of the events itself? If we inspect the element, we probably will see some of the events, the data that's coming through. Perhaps it's in here somewhere. I'm not sure if I console logged it. But really what it comes down to is the actual event model itself, as in the label, the actual data itself. So one of the things I want to do is get rid of one of the labels. I'm basically going to go ahead and come in here and say YouTube and watch event.label. I do not want it equal to queued, and that's it. As soon as I do that and I refresh my data, my total events go down significantly. That is a huge portion of this as well. So granted, we are storing that queued data, and that's okay, because then we can see how often is this thing being queued up, which can tell us all sorts of other things. But the idea here is we have queued, and that's a good idea. Now, one of the other things you might consider as well is having it in playing, and it's like only play time, as in it's the only time that's been played. That's going to be up to you on how you want to play around with that. But now our data is looking a lot better in terms of the granularity that we might want to or sort of expect with this data. So now we're really ready to go to the next phase, which would be actually seeing and aggregating all kinds of videos themselves. Let's take a look. Let's now do our top videos over like the last year. So the way we're going to do this is we're going to grab our get video stats here. I'm going to copy this entire route and I'm going to paste another version of it right below. Now within the other route, we're going to go ahead, the one above it, we're going to go ahead and say top. The reason we're putting it above has to do with that, wildcard URL parameter here. So I want to just get top video and stats, something like that. I'm going to get rid of this video ID in here because we are no longer bringing it in. It's no longer a valid argument, which means that I should be able to take it out elsewhere too. So this one right here, I'm going to go ahead and get rid of that also. So now we should have an endpoint that gives me all of my top videos. I don't really have to change a whole lot else. Now, one of the things you might be concerned about is what if there is a real video with the video ID of top versus anything else? Well, the way we solve this is twofold. YouTube itself, if we go in there and look for a video with the ID of top, it's going to give me this. So right away, I don't have to worry about that. It's just not a valid video. The other thing I could do is just move this into its own route. The only reason I don't have it in its own route right now is really just for simplicity. I would actually, in production or a real project, I would move this into its own route where it's not inside of video events, but maybe it's in like, overall metrics or something like that. But for simplicity, we're going to leave it in here right now. So the idea then is we should be able to go into our API now and take a look at all of the top videos. What do you know? We already have this data. And what we're getting, of course, are the actual IDs in here as well, all of the video IDs. So that's super cool. With this in mind, I'm going to leave it as is, and now we're going to jump into the front end and add in a front end version. This is where actually parsing the data out a little bit differently is what I actually do want to have happen. So I'm going to go ahead and say top and page.jsx. We'll start that off. And then I'm also going to go ahead and go into the watch and copy the metrics table. This is going to be top video table or something like that. And this one is now going to have a different endpoint, which is just going to be top. And we probably don't need that trailing slash as we didn't there. This is going to be our top video table now. I do not need a video ID in here at all. I'm going to go ahead and get rid of that. The next one is going to be our session ID. Do we need our session ID? Well, we have it in our headers and in our fetch. So we're going to go ahead and say yes. This time though, I don't need the video ID at all in either place. So I'm going to go ahead and get rid of those. The time bucket, we still might end up using that one. So I'll go ahead and make sure that I keep the time bucket stuff in there. Everything else is roughly the same. Not quite the same, but roughly the same. So one of the things that would be different would be another column in here that we would put and do something along the lines of video. You know, it's possible that we don't even necessarily consider the date if we're just doing for the past year, but I'm going to leave it in there also with the bucket coming through as well. So the actual, selecting the bucket unit and all that, the time bucket selector, we will leave that in too. So with this in mind, I'm going to go ahead and actually grab a new column here, and we're just going to start off with vid.videoid. So we'll do, or rather val.videoid, the name of what we're iterating through, and we can go ahead and save that. Now on my top page, I'll just go ahead and export the default function of top page, or rather top video page, something like that. And then in here, we will pretty much just return the top video table. I don't know if we really need anything else in there at this point. Top video table is pretty much handling everything else. The useWatchSession should work without that video ID. So if that video ID is null, there we go. So I'm actually going to go ahead and say if video ID like that. Otherwise, we'll just leave it in as an empty string, and we'll see if there's any errors in here. At this point, I'm going to go ahead and, instead of saying adding data to the backend, error with watch session, save that. Even if our actual top video page does not have the session data, that's probably fine. Okay, so now back into our app here, I'm going to go into that top page, and here is some of those videos. Okay, so that part is rendering. Let's see if the actual session itself, if we have any errors. I don't see any errors. There's no console logs in there. So good sign for all of that. And this is now, of course, giving us all of the data that's coming through. Now, there might be some unique data in here or not unique data in terms of the video ID, which we can handle inside of our backend. So our backend would actually handle the uniqueness of it. So we actually already kind of have one like that. So we've got this distinct in here for a video ID itself, which I'm not going to do just yet. Instead, what I want to focus on is the actual unique views. So I'm going to go ahead and cut this out, and we'll go ahead and say unique views equals to that. So that little function, that calculator there, I can still use that as a select. If I save it and refresh, still works the same. Why did I do that? Well, it has to do with the unique views column. So really the order by is going to go ahead and do the same thing. We can use that unique views function as a way to order it as well. As soon as I refresh, I see there are my unique views, and here's all of that data. Now, of course, the actual duplicate video IDs are still in here, so it's definitely something we're going to want to update at some point. But for right now, we have the ability to see how things are doing and how things are doing recently. So the other part about this, of course, is the chunking in here. So that will make a difference in terms of how these videos are being rendered. So we see hours in here, so it's kind of duplicating some of them in those hours. And the next thing, what I want to do is just make a little change to it by going into one of these videos. So if I go back into my local host, the cool thing about the local host now is I can actually put in local host and then 3000, and then we can do watch $v equals, and this should still work as well. Make sure you don't have a space there though, and then go ahead and run that. That also opens up this other video, and we could go through that video as well. And of course I could also open this up in an incognito window and paste that in there, do it again just to get some unique views in here, and there's those unique views and also the session data as well. So pretty cool. And then if we go back into top, what I can do is in the last few minutes, I can see what's trending in the last few minutes, and there's the video that's trending in the last few minutes. All of this stuff we obviously are going pretty fast on, and we could optimize a lot of different things about it. But overall, it's actually super powerful that we can do this in practically no commands at all. Like, it's actually pretty straightforward, and it can handle a lot of this data. So of course, we're going to want to talk about like approaches that we would want to use to have this data. It has a lot to do with caching the results here, because realistically, you're probably not going to try to get up to the minute information about videos. Every once in a while you might, so there's definitely the possibility there. But overall, this is actually pretty great that we can now see these top videos. Now, you might also want to link the actual video itself, and you might want to actually store additional video data and then merge that data when we're displaying it in the tables themselves. But as far as linking is concerned, it's pretty straightforward. We just use the link class that's inside of Next.js. We use href, and then it's going to be a watch v equals to the val.video ID. I'll go ahead and put that $sign in there for the string substitution, and then we will surround the video itself with that link. And so now I can actually select any of the videos that are trending, and then it would show up. Pretty neat, if you ask me. And so now we've got a way to track videos, see all the analytic data. Every once in a while, you might have a video that's invalid, so we might have to do some stuff with that in terms of optimization for the links. So one of the things you might consider doing, if that's not working for some reason, you can just change it into a link and maybe put something like time equals 0 or something like that. That might actually solve that problem a little bit for us. I would just need to check it by going to the different links in here. And it looks like we've got an issue. So we've got player info. So it has something to do with just refreshing the state of the actual video itself. So not necessarily something we'll cover right now, but the idea here is we have the top videos showing up. We've got trending data by actually being able to go in, hey, what's happening in the last hour? What videos are popping off in the last hour? And we could obviously narrow back the responses, right? So as it stands right now, we've got it for the last few months. So if we only wanted it for the last hour, we could do that by just doing, instead of fallback being 24 hours, we could just say 1 hour. So in the last hour, these are going to be the top videos that have been played. So if we refresh in there, obviously it's done by chunks still. So those chunks will still try to go out months and all that. But in the last hour, these are the things that went trending, if you will, based off of all of this data. And you can see it in here for the last few hours, which is great. So obviously we could up that up to 10 hours or something like that if you really wanted to see the trending video. So not only could this be top historically, but it can also be top in the last however many minutes, all chunked down thanks to all that time series data. It's pretty great. Hey, thanks so much for watching. Hopefully you got a lot out of this. And thanks to Timescale for sponsoring this course and helping bring it to life. Be sure to go to this link right here and sign up so we can make more videos like this, leveraging Postgres and time series data, because that's exactly what Timescale does, and that's why this course exists. Now, I will say there are still things that we can do to improve the way we use this course, the way we use this data. Now, a big part of it is, yes, we definitely want to have these aggregations, and we can do it very simply. But what we might want to do now is take snapshots of this data so it's stored like per day. So every day we see what the video stats are for that day for any given video, and then we can still do those same aggregations for our top video stats. But the thing that Timescale does really, really well is ingest that data, and then it can chunk it for us. But if we want to keep that data over time, we might do those chunks every day. We take a snapshot of a chunk every day. That way, if any of the data ever gets removed, because it does after whenever we actually finish storing it, right? So we've got this drop after interval in there. So if it does drop, taking those snapshots will at the very least keep a record of what happened in that day. That doesn't mean you keep all of the watch events, but rather you would keep the results of the aggregations that we looked at, because that's more of the important data in there, especially when it comes to individual videos and how they might have performed on that day historically. You probably don't need all of the events that happened in that day from 3 years ago or even 2 years ago. You probably only need that data in the last 3 months to really make really strong decisions in terms of analytics. Now, you might imagine all of this data can get wild out of control. You could have so much data. So having a lot of diligence in terms of how you're going to chunk the data, like how you plan on chunking the data and getting most of that data, and then also how you're going to end up dropping that data. So that's a big part of it as well. And that's why using something like Timescale's actual cloud service will make this a lot easier than you trying to figure it out on your own deployed version, because scaling up and doing all that, that's what Timescale will help you do right inside of the actual managed service itself. And so if you are going to be using this in production, that's the way I recommend doing it. For examples like this, or even just getting your feet wet with it, you can absolutely do the open source version as you see fit. But of course, I don't really want to manage what happens to this data in a year. I don't want to think about that. I just want it to work. And so those are two strategies on how you might go about doing it. Just doing a worker process to do snapshots, and then also using the actual Timescale cloud because it has backups and handles all of the chunking and dropping of data for you if you need to have all of that historical data inside of Timescale itself. So both things are really important to consider, but thanks again for watching. My name is Justin Mitchell. I enjoyed taking you through this one, and I look forward to seeing you next time.